तो उसमें एक मैसेज डाल
Professor Honesty.
ठीक है ना चलो
ये होता रहेगा क्या अपना
ये होता रहेगा यहाँ चला के छोड़ दे
हेलो
Good morning, sir.
Good morning. Am I audible?
Yes, sir, you're very much audible, sir.
Thank you.
So how are things there, sir, at your place? All good?
Yeah, all good.
That's nice, sir.
Now there are some cases in the campus also now.
Yeah, it started here also, sir. Same here.
Okay.
Few cases in the campus, at the campus.
A very warm welcome and good morning to all present in the inauguration ceremony of 5 days online STC on security and privacy challenges in computing paradigm. Greetings to all the dignitaries present, Professor L.K. Avasti, Director NIT Jalandhar, Professor Sinha, Dean RNC, Professor A.L. Sangal, Head Computer Science and Engineering, Professor Harsh Kumar Verma, Head Computer Center, Dr. Geeta Sikka, Associate Dean Faculty Welfare, Dr. S.K. Mishra, Registrar, NITJ, my colleagues and dear participants. We have arranged eminent experts from IIT, NIT and industry experts like IBM for this STC on security and privacy challenges in computing paradigms. Nearly 800 participants have been registered for this course. So with the aim of imparting knowledge in computing paradigms, Professor L.K. Avasti motivated us to put the guidance and support of our worthy director, a visionary leader, to motivate us for this event. I'm feeling proud to share that under his dynamic leadership, NITJ has reached at 52 NRF ranking and placed in the band of 1125th rank among various educational institutions by Ajal ranking of institution. I'm feeling glad to inform you that under this pandemic situation, NITJ family has worked diligently for the upliftment of knowledge through online courses, virtual conferences, and R&D activities. Also, 4 patent and 1 technology transfer has been made with respect to COVID-19. And total of 11 patent and 3 technology transfer has been done during 3 months. We are very fortunate to have such a great mentor with us. Now to start with the formal inauguration address, I would like to call Dr. Geeta Sikka, co-convener of this course, to please share her views about the course.
So a very good morning to one and all. It's a pleasure to be here today with the Honorable Chief Guest of the event, Professor Manoj Mishra ji from IIT Roorkee, Professor Lalit Kumar Avasti, Director NIT Jalandhar, Dr. Sinha, Dean RNC, Dr. S.K. Mishra, Dr. Professor A.L. Sangal, Dr. Harsh Verma, Convener of the course, Dr. Aruna Malik, Dr. Prashant Kumar, faculty members of the Department of Computer Science and Engineering, and various other department faculty members who are joining us through Google Meet, and my dear online participants. On behalf of the Department of Computer Science, a very warm, a wholehearted welcome to this online STC on security and privacy challenges in computer paradigm, which will be run. Which will be run. Is the voice breaking? Hello. So this STC will be run from September 1st to September 5th, 2020. And the response, as told to you by Aruna Malik, Dr. Aruna Malik, has been awe-inspiring, with over 800 plus participants registering. While some join us on Google Meet, the others are catching us live on YouTube. So I take pride in welcoming Professor Manoj Mishra ji, the chief guest and resource person of this e-program. So your presence here is truly momentous for us and very encouraging, not only for the participants, but also for the Faculty of Computer Science and Engineering at NIT Jalandhar. So thanks for your willingly accepting our invitation and being here with us today, sir. So your talks not only bridge the academic research, with daily life, but also demonstrate how security and privacy impact and augment our everyday existence. Thank you so much, sir. In a short while from now, the participants will have the privilege of listening to him. Thanks to Professor Awasthi for inspiring us in organizing the most exciting, informative, stimulating, and memorable events from time to time. Thank you so much, sir, for your support. Your support has been commendable, and thank you for being with us always and today for the inaugural ceremony. Thank you. Out of the series of STCs by the Department of Computer Science and Engineering in the past 2 months, 3 have been focused specifically on security, but the first being on cyber security, followed by a second one on identifying the weakest link, wherein we had a very renowned speaker, Professor Bharat Bhargava from Purdue University, West Lafayette, Indiana, and now this is the third one on security and privacy challenges in computer paradigm. So this highlights the need of security in the new information era that has transformed the way we create and share, and rightly so the need of the hour. As the nation struggles to navigate this coronavirus, there is a community eager to take advantage of this crisis. Another devastating crisis is brewing in today's digitally connected world. The global cyber pandemic is now the reality. And according to the news, the reports, the world has witnessed a staggering 400+ increase in cyber attacks. So in this era, with high internet penetration, with exponentially more and more people working remotely, with increased use of IoT and cloud-based services, we must stand up to the challenge of protecting our data, and we must act now if we want our societies, nations, and people more secure and allow for internet to drive the benefits of improving every aspect of life that it pervades through today. So rightly said, vaccination is better than treatment, and the same applies here. So real-time prevention can help us be in a better position to defend against the next cyber pandemic. So this STC has been rightly planned at the right time under the guidance of Professor Awasthi, and we wish and hope this turns out to be a fruitful one. Thank you one and all, and I look forward to a very fruitful sessions that follow. And now I invite Professor Verma to say a few words. Thank you.
Yeah, Honorable Professor Mishra, Dr. Lalit Kumar Awasthi, Director of the Institute, Professor S.K. Mishra, Registrar of the Institute, and dear participants. I formally welcome you to the TCUB3 sponsored online short-term course on security and privacy challenges in computing paradigms from September 1st to September 5. About Department of Computer Science. Department of Computer Science and Engineering was established in the year 1988 with BTech program with 40 seat intake. Now at present we have 120 seats in computer science BTech program, and we are also running two MTech programs. One is in computer science, another is in computer science and engineering with specialization in information security. And department is also offering a PhD program in computer science and engineering. And recently, like Madam Geeta Sikka has told, department has been instrumental in conducting short-term courses and conducted a number of short-term courses. For example, she told you we conducted on cyber safety, identifying the weakest link, applications of machine learning, then STC on research advances towards leading investigators. Then recently we have conducted short-term course on soft computing techniques and its applications. So this course is in the series of those short-term courses. Let me brief up about the eminent speakers which we have requested to deliver lectures for. The inaugural lecture will be by Professor Manoj Mishra, an eminent professor at IIT Roorkee. Then we'll have Pillai and Emil from NIT Jaipur in the afternoon today. Tomorrow we will have Professor Sanjeev Sofat from PEC Chandigarh, and in the afternoon we'll have Narottam Chand from NIT Hamirpur. Then on the third day we'll have Durga Toshniwal, Dr. Durga Toshniwal from IIT Roorkee again. And in the evening session we'll have TP Sharma from NIT Hamirpur. And on the fourth day we'll have Dr. Maninder Singh from Thapar University in the morning. And in the evening we'll have Dr. Naveen Chauhan from NIT Hamirpur. And the last day we'll have Dr. Mani Madhukar from IBM. And then finally, we have concluding ceremony and concluding remarks by Professor Lalit Kumar Awasthi. Last lecture will be by Dr. Lalit Awasthi. So these are the list of speakers which will be delivering talks during the 5 days. I understand there will be a lot of learning during these 5 days, and participants will be benefited out of this course. So I once again welcome you all. Especially I am thankful to Professor Mishra ji, who has been very kind and he always accept our request and deliver such talks at NIT Jalandhar. Thank you, Dr. Mishra, once again. Thank you.
Good morning. Greetings from NIT Jalandhar.
Good morning, sir.
Honorable Professor Manoj Mishra ji, the Chief Guest for inaugural session. Dr. Harsh, Dr. Geeta, and the organizers, the coordinators, Aruna Malik and Prashant, and the faculty members from NIT Jalandhar and all the participants. It's my privilege to be here on inauguration of the security and privacy course, short-term course conducted by Department of Computer Science, and there have been a series of such courses. So what is the reason we are conducting so many courses related to security and privacy and other things? So the main thing is, one is the job market. You can see that the kind of courses, the total number of jobs available and the person to take these jobs, there will be deficit by 3.5 million in 2021 in security area. So this is one reason. And the second reason, all of you know, is that there have been so many cyber crimes and cyber criminals that they have created an atmosphere of uncertainty in the minds of common. So by looking at these statistics, it's very important that everyone should be well informed. So due to this only, there is another area which is cyber forensic, and for which Professor Manoj Mishra ji is a very good expert. He and his team, the students, are working on forensic. At NIT Jalandhar also, we have a couple of students working in cyber forensic. So I definitely feel that this is the need of the hour, not only the unliterate person in education, but those who are literate and who knows, they also are caught into this cyber crime. So I hope the kind of the galaxy of experts which have been invited, Professor Manoj Mishra, Professor Sanjeev Sofat, Professor Durga Toshniwal, and many more, they'll be able to give quite good input to the participants. And I hope everyone during this pandemic situation stay well, and humanity as a whole come out of this pandemic at an early time. Thank you. Jai Hind, Jai Bharat.
Sorry, Aruna, you're not audible. Aruna, you're not audible.
It's a great pleasure for me to introduce the chief guest and expert speaker of this STC, Professor Manoj Mishra. I wholeheartedly welcome him. Professor Manoj Mishra obtained his PhD from University of Newcastle upon Tene, UK. Currently, he is a professor in the Department of Computer Science and Engineering at IIT Roorkee. He is also a chairman of Department Administrative Committee. Professor Mishra has more than 35 years of teaching and research experience. His research interests include distributed computing, performance evaluation. He is involved in many research projects and consultancies like MHRD, Government of India, project, etc. He has to his credit of publishing 111 research papers in international journals and conferences. Professor Mishra is also an active reviewer of many international and national journals. Now I request to Professor Manoj Mishra, sir, please join us for a great session.
Hello.
Yes, sir.
Thank you, Dr. Arna. Am I audible?
Yes, sir, you are audible.
Okay. Thank you, Professor Sikka and Professor Harsh also. And thank you, Professor Lalit, for inviting me to deliver a talk in this STC. And obviously, as Professor Sikka mentioned, that this is the time of Corona and it is not possible to physically meet, but then probably I have seen that if we are conducting online courses, then probably the participation is more than if someone has to come over there and attend physically. So I always found that Professor Awasthi is very motivating and very hardworking. And this is obvious because I've seen that NIT Jalandhar is organizing so many such courses on security and other topics. So I will not take much time for this inaugural talk. And what I'll prefer, if you permit me, then I'll switch over to my lecture directly.
Sure, sir. Sure, sir.
Okay. Thank you very much. And thank you, Professor Lalit, Professor Sikka, and Professor Harsh Verma again for inviting me. So I'll share my screen.
Our privilege, sir. Thank you so much.
Okay. So the slides are visible?
Yes, sir.
Okay, thank you. So today I'll talk about cyber crimes and network forensic in general, and particularly about the work that we are doing on identification of hosts behind the mat. So to start my talk, I don't know how many of you have seen this particular website. If you go to this website, digitalindia.gov.in, it talks about the Digital India initiative of our government, and particularly it says that Digital India is a flagship program of the Government of India with a vision to transform India into a digitally empowered society and knowledge economy. So, the government is trying to push e-governance and
Sorry to bother you.
India.
Sorry, Manoj, sir. Sorry to interrupt you.
Yes.
There is some disturbance in the voice. Some disturbance in the audio. Actually, there is a chat box where people are writing. Participants are writing. This is disturbance. Yes, sir.
So let me see.
Sorry to interrupt you. There is some disturbance in the voice. Some disturbance in the audio. Actually, there is a chat box where people are writing. Participants are writing. This is disturbance. That will be better.
Okay. Okay.
So participants, kindly hold. Professor Mishra is going to join us in a minute.
So am I audible now?
Yes, sir. Yes, sir.
So as you have seen that Indian government is pushing towards e-governance and trying to make India as digital India. And I'm very sure that all of you have used e-payments, e-marketing, even if you have not or probably not part of e-governance, but many of you may be also. So whenever we talk about these things, we talk about online services, be it e-payments or be it e-marketing, it simplifies our lives. It reduces the operational cost which is involved in offering a service. So these are the benefits of these things. But at the same time, when we are using these online services, it requires that the person who is using these services, he should know something about how to use these services. So it requires a certain degree of technical sophistication from the person. Otherwise, it increases the possibility of frauds. So these are some of the cyber crimes or cyber attacks, which probably you will find when you will surf the net, you will find these names: phishing, man-in-the-middle attack, malwares, denial of service attack, SQL injection, zero-day exploit, DNS tunneling, and the list doesn't end here. There are many more: hacking, data leaks, cyberbullying. There are so many other things. And in fact, it is the race between the attackers and the persons who are defending us from these attacks. So if you visit the site of the Interpol also, it says that the cyber attacks, they know no boundaries and they evolve at a rapid pace. And that is basically because these cyber attacks, they use internet, which is worldwide, and an attacker sitting at a remote place can easily attack your machine. And he can remain anonymous because of the large number of machines, billions of machines connected to internet. It is very difficult, it becomes very difficult to find out that from where the attack has happened or which machine has been used for the attack. And cyber crimes, they take advantage of online behavior and trends also. So recently, because of the corona, you will find that many cyber crimes which are happening, they are hidden behind this pandemic. So many mails that you are receiving, they will tell you something about the corona and they will ask some information from you, or they will say that, okay, this is the website which gives you some information regarding this pandemic and how to handle this. And then probably they will ask you to follow some links. And if you are clicking on those links, they will install some malwares on your machine. So Interpol divides cyber crimes into pure cyber crimes and cyber-enabled crimes, where pure cyber crimes are the cyber crimes where the attacker is directly attacking your machine or the machines on your organization or the network which is connecting these machines. And into the cyber-enabled crimes, they put those crimes into this category where the crimes, they were there earlier also, when the network was not there, when the internet was not there, when the computers were not there. For example, gambling was still there, but now people, they are using gambling, they are using internet for gambling. So they put such crimes into cyber-enabled crimes. And generally, the reason why these attacks, they happen, they are because the persons who are using the internet, they know a little about how to access the internet or which site they should access, which site is dangerous or they should not access, which attachment they should open, which attachment they should not open, on which link they should click, on which link they should not click. Sometimes we know these things, but because of the bounded attention, we ignore the warnings which our browser gives or which our email client it gives. Then the speed and the size of the internet is also responsible for that. As I said, that because of this size, it becomes very difficult to find out that which machine or which set of machines they are involved into the attack. Then the design of the TCP/IP protocols is also one of the reasons, because when these protocols, like the protocols TCP, UDP or IP, they were being designed. So at that time, the researchers who were designing these protocols, they never thought that these protocols, they will be used for implementing such a huge network like internet. And so in many cases, the authentication part, the security part is missing. And another reason is because the way these softwares are developed. So in some cases, vulnerabilities are there, bugs are there, and attackers, they exploit these vulnerabilities, they exploit these bugs in order to attack or in order to perform a cyber crime. So forensic science is basically the science, the application of science to law, where we are searching for the evidences So you may have heard about forensic a lot. So a crime happens and sometimes the news is there that fingerprints have been sent to the forensic lab for examination and all those things. So digital forensic is a branch of forensic science, or you can say that it is the art or science of gathering evidences either during or after a crime in digital world. So when you are using computers, these computers, they are connected with each other through a network, through internet, and the crime has been done using these devices. So how to collect the evidences and how to reconstruct the criminal's actions so that we can provide the evidence for the prosecution of the criminal. So basically, whenever we are using these devices, we are using internet, you can see that we have a world and a digital layer is there. So whether a person is sending a message to someone else, it may be a threat message, it may not be a threat message. You are using your computer in order to communicate with someone else, you are sending an email, you are downloading a file, or you are using your mobile phone, you are using your smartphone for doing these things. So any digital activity, it leaves traces. And digital forensics says, or the main task is to collect these evidences, to gather these evidences from the information which is available, the data which is available on these devices, the traffic which is on the network. So to collect the evidences so that these evidences, they can be used in the court against the criminals. So there are various fields of digital forensic. So digital forensic, or rather various branches of digital forensic. So you can say that we are dealing with cloud forensic or mobile forensic or computer forensic or network forensic. So whether we are dealing with cloud forensic or mobile forensic, computer forensic or network forensic, the objective is same. You have to gather the data, you have to find out the evidences, from where to collect this data. So generally it is the logs created by the operating system. So we want to know that what processes were running and what these processes they have done, or what software applications were running and what data has been modified or what messages have been sent by these software applications, the databases which are there, what changes have been done into the databases, what sites have been visited using your internet browser. So all this information, the objective is to gather this information. Now it depends that which particular branch of forensic we are considering in. So say, for example, if we are talking about computer forensic, the objective is to collect the information from the hard disk of the computer. Maybe we want to capture the snapshots of the volatile memory also. But when we are talking about network forensic, the objective is to collect the traffic which is there onto the network. So to capture this network and to find out the information from this traffic. So depending upon which branch we are dealing with, the location from where we are collecting the information, how we are collecting this information, what information we are collecting, that may change. But ultimately the objective is that we need to collect the data, we need to find out the information from it, and there are set procedures for doing this. So in general, when we are talking about digital forensic, there are many process frameworks that have been proposed in the literature. So I'll discuss about the process framework proposed by NIST. So it says that there are 4 phases. The first phase is involved in collecting the information. So basically here we have to identify that from where the information should be collected. So we are concerned with the media. So whether the information should be collected from the hard disk of a computer, or we are interested in collecting the information from the which was there from the volatile memory, or it is the memory in your smartphone, or it is the traffic onto the network. So we need to identify this. We have to record this information. Maybe we have to make certain copies of it. So you need to make the clone of the hard disk that you have captured from some machine, which was, you think that it was involved in performing the crime. And maybe in some cases you have to do the labeling of this data also. Then once we have identified the media and we have collected this information, we need to examine this information. So we have to filter. So probably the traffic which is flowing onto the network, you have to decide that whether we are interested only into the headers of the packets which are there, or we are interested into the payload of the packet. Maybe the requirement is that we need to extract the hidden files or the hidden data which was there onto the hard disk, the files that have been deleted. And obviously, integrity checks are performed so that when you are making a clone of a hard disk, there is no modification of the data, there is no change, no information loss is there. So we need to perform integrity checks. And then the analysis is done, which transforms the data into the information. And there are many methods that can be used for analysis, which ranges from statistical or behavioral analysis to searching for the pattern, or doing data mining, using fuzzy logic. So many different methods can be used for doing this analysis. But ultimately, the objective whenever you are doing this is to get some information from the data which is available. So, yes. And the last phase is reporting, where we are looking for the methods that should be used for the visualization of the data and the information. You may use some decision support system. We are worried about how the documentation should be done and what recommendations should be done, and obviously how the information should be visualized and how these recommendations should be made. It also depends upon that for which we are making these recommendations. So whether it is for the court or from some higher authority for my boss. So different methods are used for that. Because we are concerned here with network forensic, So I'll talk more about network forensic. And as I said, forensic science, in the case of forensic science, the objective is to search for the truth or to search for the evidences. In network forensic also, we are searching for the truth or the evidences that can protect users and resources from exploitation, invasion of privacy, or any other crime. But in this case, we are doing this by studying the network traffic. So we are interested in capturing the network traffic and analyzing this traffic, extracting the information from this traffic or the data in which we are interested in to find out that how the crime has happened, who has done this crime, and all this information. So the techniques which are used for network forensic, they are not only used for forensic, they are used for security purposes also. So for example, if you are using a tool for detecting the intrusion, so then probably your objective may be to provide some kind of security only, not the law enforcement. But there is lots of overlapping between the techniques and the tools which are used for security and for collecting the information or the evidences for law enforcement. So when you are doing security, your objective is to monitor a network for anomalous traffic and finding out the intrusions. But when we are interested in capturing the traffic or analyzing this traffic for law enforcement, then probably we are interested in reassembling the transfer files. So the data which is there into the payload, you may need to reassemble the transfer files, or maybe we are searching for the keywords to identify that who has done this crime, the traffic originated from which machine.
Hello?
Yes, please.
Mishra sir? Mishra sir?
Enforcement, then probably interested in reassembling the transfer files.
Sir, there is some noise coming from your side.
Reassemble the transfer files, or maybe we are searching for the keywords to identify that who has done this crime. Okay, what should I try? I will try headphones. Just tell me that whether it is better with headphones or it is better with the mic which is there of the laptop. Is it better now? Okay, what should I try?
Not, sir.
Okay.
Sir, voice is not clear. Noise is coming.
Okay. Hello.
Yes, sir. No, not, sir.
Not clear.
Sir, voice is not clear. Noise is coming.
Hello.
Yes, sir.
So am I audible now?
Yes, sir. Now it is audible.
Okay. So when we did work on network forensic,
Yes, sir. Your voice is clear.
Okay, thank you. So when we did this work on network forensic, our objective was to identify the machine which is actually involved into the attack, and particularly the machines which are hidden behind some NAT device. So network forensic analysis, it basically involves traffic capturing, and generally the two techniques which are used for capturing the traffic is catch it as you can, where we are actually capturing all the traffic which is flowing. So huge amount of storage space is needed. Whereas in the second technique, which is stop, look and listen, we are analyzing the traffic and we are capturing only that part of the traffic which is of interest. So now the less amount of storage space is needed. So maybe we are interested only in headers and not the payloads. So we are only storing headers and we are not storing payloads. Or maybe we are interested only into the TCP traffic and not the UDP traffic or ICMP traffic. But then we need a fast processor, because when these packets, they are flowing, we need to not only capture them, we need to analyze them also before storing them, or before making this decision that what should be stored and what should not be stored. And then comes the analysis when we have captured the traffic. So the methods, they can be basically categorized into two categories: attribution based methods, where maybe we are using some of the attributes of the traffic which are there into the traffic, and we are trying to find out that actually which machine is actually generating this traffic. And there are non-attribution based methods where we are interested probably in something else. For example, you are not using attributes, you are adding some other information with the packets which are going from source to destination, and based upon that you are trying to find out some information, or maybe we are doing some kind of correlation analysis, or we are interested in history. So there are two categories of the methods, and we basically worked on attribution based methods, where we captured traffic and then we analyzed some of the fields of different headers, and based upon that we actually the objective was to decide that from where this traffic is coming. And the final part is how to present this information, or the information that we have gathered from this analysis. So the methods that should be used for that. And obviously another important thing is that how to store this information also when you are doing this forensic. What methods should be used for that, because this information may be needed maybe into the court after 10 years. So the aim of the analysis is these 4 W's: who, this relates to attribution; what, which, where we are actually trying to determine the impact of the attack that has happened, and what was the motive behind the attack; when, which is interested actually that when which particular event has happened, so the time of each event to get an accurate picture of the crime. And finally, the last W says where, so the location from where the attacker has operated, so the machines that have been used into the attack. There are many challenges when we are dealing with network forensic. One is high-speed data transmission. So as I said, that you have to capture the traffic. Now think of that, if we are transferring, we are dealing with a link which is 1 Gbps, and 1 gigabits are, you are transferring 1 gigabits per second, and each packet is say probably 1000 bits. So how many packets you have to capture in 1 second, and you have to analyze these many packets into the capture, and then probably if you are doing this, you have to also transmit these packets. So then another thing is that from where we should capture this traffic. So should it be a centralized location? Should we assume that all traffic will go through this particular central location and we are capturing the traffic there? Or should it be distributed? Even if it is distributed, where to put our traffic capturing software, where to install, on which machine, should it be the router or some other device. Then data storage on the network devices is another challenge, because if we want to store this traffic onto the intermediate devices, say routers or switches, then we have to see that what is their storage capacity, how much data can be stored there. Another issue is data privacy, and the final issue is data integrity. So privacy should not be violated, and when we are capturing this data, then we need to perform certain integrity checks so that we can detect that data has not been changed, no loss of information is there. There are many tools for capturing and analyzing the traffic. So I've given this list. The list is not complete. There are many more. I've just listed some of them. For example, TCP dump, we use this Wireshark for capturing the traffic. Then wind dump is there, solar winds is there. And obviously, all of them, they can be used for capturing and later on for analyzing the traffic. But when we come to analysis, then their capabilities may differ. So whether they do flow level analysis or they do packet level analysis, basically the concentration is more on analysis of protocols, or they can do the analysis of the data which is there into the payload also. So you have to study and you have to find out that which particular tool is most suitable for your work. Then there are certain specific task tools like Snort, Bro, which are used for intrusion detection, SSL dump for extracting SSL related information. We use this Tran analyzer for some of our experiments, which is basically a flow generator and packet analyzer. So we can group the packets into flows, and then we can find out that how to assign these flows to different machines. Then there are certain libraries which are available, and you can write your own programs, you can write your own tools using these libraries like litpcap, WinCap, and there are many more. So how it is important to find out that from where the attack has happened. So I'm just showing this survey done by the Carnegie Mellon University along with CSO. So the e-crime was survey. So there were 500 people who were involved in this survey, and 95% of them, they said that criminal activity, it leaves any sort of digital traces. So whenever any criminal activity happens, then some kind of digital trace is there. And they said that 70% of these cases, they are generally not handled. And in 50% of the cases, the reason is that either the evidence is not collected properly because the data has not been captured properly or has not been stored, or there is not even if the data is available, it is not possible to identify based upon the information or the data which is available, the host machine that was involved into the attack or the crime. So identification of source is an important thing, and it's a big challenge also in network security and forensic analysis. In the literature, traceback techniques, they have been proposed, and they are used also to detect the real source of traffic. They are generally used to identify the sources where the source IP address is spoofed, or probably, so when the packet is traveling, the source IP address is not the actual source IP address, or probably the machine is behind the NAT. So in case of that also, the source IP address which is there into the packet is not the actual source IP address of the machine which was involved into the crime or into the attack. So I've just mentioned few things. So for example, if someone says that I have received a mail from a friend, and the mail, it contains a link and attachment, so it is safe to click the link and open that attachment. So how true this is? Or I have deleted a file from my hard disk. Now no one can now see this file. Or I have sniffed a packet and I can find out the source machine by just checking the source IP address, or maybe by just checking the MAC address, which is there into the header of the data link layer, MAC. So all these are misbeliefs, because the email ID of your friend can be spoofed. So when you have received a mail and the mail says that the mail is coming from your friend, it may not be actually your friend, and the link or the attachment there may be malicious. If you have deleted a file, so generally when you are deleting a file, what happens, even when you are formatting your disk and you are doing a quick format, the contents of the file, they are not deleted. Only the data structures which are maintained in order to locate these files, they are deleted. So unless and until you are writing all zeros in every location of the disk, you cannot say that if I have deleted a file, then no one can see this file. And similarly, as I said, that because IP addresses and MAC addresses, they can be spoofed. So just by looking at the IP address or the MAC address into the packet, you cannot tell that from which machine the packet has been sent. Now, spoofing of IP addresses and MAC addresses is not only done by malicious reasons. There are legal cases also where we need to do IP address spoofing or MAC addresses. Probably when you are on a public Wi-Fi, your mobile phone may not send the actual MAC address of your mobile phone when it is contacting the access point. So I've just added 1 or 2 slides to show that how easy it is to do the IP address spoofing. Now there are many tools which are available for doing this. So if you have used Socket API and if you have done socket programming, I'm sure that you may have used TCP and UDP sockets. So similar to using TCP and UDP sockets, you can use raw sockets also. Now the raw sockets, they can be only used if you are a privileged user. And these sockets, raw sockets, they are generally used to bypass the normal TCP IP processing. So normally what happens, because there is a layered architecture, so when the IP layer, it gets a packet, it examines the IP header, and then depending upon the protocol which is there into the protocol field or the number which is there into the protocol field of the IP header, it passes it on either to TCP or to UDP, and then TCP, say suppose TCP is there, then TCP examines its own IP header and then finally passes it on to the application layer. So if you are using raw sockets, then this normal processing where the IP layer is sending the packet to TCP or UDP layer or some other protocol which is at the transport layer level, it can be bypassed. And the packet can be directly sent to the application layer. So in many cases, raw sockets, they are used to generate and receive packets of the type that the kernel doesn't explicitly support. So if the code which is there onto your machine for examining the IP header, and when it finds that there is some number into the protocol field of the IP header which it doesn't know, then it can examine that whether there is some process which is running, which has opened a raw socket, it can send this packet to that particular process. They are also used to read and write packets of the protocols like ICMP, IGMP, which are actually not TCP or UDP packets. Or raw sockets can be used when you want to control the IP header. Or in other words, I can say that when I don't want that the IP module which is there on my machine should build the IP header, rather I'm interested in building my own IP header. So obviously we cannot build a complete IP header, but most of the fields you can write when you tell that I'm interested in, or when your application tells by using certain mechanisms that will see that I'm interested in building my own IP header. And these raw sockets, they are used by applications like ping, traceroute, network address translators, NATs, and firewalls. So when you are using a raw socket, so there is a function in socket API socket. So there you can specify that you actually want to use raw sockets. Now, as I said, that only a super user can create a raw socket. But now, when you are using your laptop and you have installed, say, probably Linux on it, you can easily work as a super user there. Or you can run your application with super user privileges. And a process can use this function set socket options. So I'm telling just one of the way of doing this. There are many other ways, and as I said, that there are many other tools also there that you can use, and then you don't have to do any programming actually. So you can use this function from socket API, set socket option, and you can tell the kernel that whenever.
Hello.
Yes,
Sure,
please.
sir. Sir, there is a noise coming from your side.
Actually, I will close my fan. I don't know. Is the noise still there?
Yes, sir.
It is still there.
Yes, sir.
What now? Is it still there?
Yes, sir.
Or is it still there?
Good afternoon, sir.
Can you tell me now?
Sir, now it's perfectly fine.
Okay. So you can tell the application can tell the kernel that when I'm sending you the data, this data, it contains the IP header and any other header which is needed before the IP header. So the headers which, if needed, of the transport layer protocols also. So it can tell that IP header is inclusive. So I can set this, I can call this function, I can inform, my application can inform the kernel. So when the application builds the IP header, then the application can write any address into the source address field of the IP header. And that actually gives you the capability of doing IP address spoofing. So this is just one way. So in fact, before going to the work that we have done, let me briefly discuss the IP traceback schemes that have been proposed for identifying that from where the packet has originated when the IP addresses they are spoofed. So now there are many IP traceback techniques they have been proposed into the literature, and they are generally used for determining the origin of the packet. In case of spoofed IP addresses, they are used generally for intrusion detection, to handle DDoS attacks, and for network forensic also. So as I said that because of the trusting nature of the IP protocol, the source IP address, so when a router it gets a packet, it never authenticates the source IP address which is there into the IP header. So because of this, the source address into the IP packet can be falsified. So if source IP address of my machine is say A, and if I'm using those functions which I've just explained, and into the IP header I'm writing B as the source IP address, then the switch or the router which is going to receive this packet is never going to check that whether the packet is coming from the machine which has IP address as A and not B. which actually can be used for performing many type of attacks. So these IP traceback schemes, they can be classified into many categories, like packet marking based IP traceback schemes have been proposed into the literature, log based schemes have been proposed, ICMP traceback schemes have been proposed, link testing and some hybrid schemes have also been proposed. In packet marking based, both deterministic packet marking and probabilistic packet marking based schemes, they have been proposed. So I'll not go into the details. I'll just briefly tell you about the packet marking based schemes and log based schemes, just to give you an idea that how traceback can be done using these schemes. So for example, probabilistic packet marking based scheme, what it says, say we have two LANs, the attacker is actually on LAN 1 and not on LAN 2. Yeah. So all the packets which are originating from LAN 1 and LAN 2, the intermediate routers, they are marking these packets. So how they are marking? One of the thing is that because this is probabilistic packet marking scheme, and say if the probability says that, okay, mark one packet out of every 100 packets, so they are randomly choosing some packet out of the 100 packets, and then they are putting some information into the packet. So the question comes that where they are going to put this information and what information they are going to put into this packet. So generally the schemes, they suggest using this identification field into the IP header, which is a 16-bit field. And obviously if you have only identification field is generally used when the fragmentation takes place, otherwise it is not of much use. So in those cases, in most of the operating systems, what they do, they just put a 0 into the identification field, and the schemes, they suggest that we can use this field for storing some information related to the intermediate routers. So one of the question is that what information should be stored. So either the information can be node specific, so the router is storing its IP address into this field, and obviously because the IP address is, even if we are talking about IPv4 addresses, IPv4 addresses, they are 32-bit and not 16-bit. So in that case, they have to store this address in two different packets. Yeah. So the complete address cannot be stored into one packet. So what the router then it does, it randomly selects two packets out of the 200 packets, and in one packet it stores 16 bits, another packet it stores another 16 bit, and if you want to store some other information also, then probably it needs 3 packets. In some cases it is not the node specific information. The schemes, they suggest that the information should be edge specific, because then the chances of false positives, they are lesser. So in that case we need to store the information about the edge, which includes the IP address of this router, the IP address of this router, and maybe some information regarding this edge, that how much time it takes to travel from R4 to R7, or what is the distance, or how, some information regarding this. So the information can be node specific or it can be edge specific, and generally the identification field has been suggested for storing this information. And because 16 bits are not sufficient, so the information can be stored, can be broken into fragments, and it can be stored into multiple packets. So, but then in that case, the victim has to receive enough number of packets to reconstruct the path. That is one of the drawback of this. So these schemes, they produce many false positives, and it may happen that the value written by a router, if the router is very far away from the victim, it might be overwritten by the routers close to the victim. So for example, if R4 chooses a particular packet, this packet, to store the information, and then no one is going to stop R7 to choose again this packet when it reaches to R7. So R7 also selects that, okay, the information should be stored into this packet only. So the information will be overwritten. It also requires modification in existing protocols to implement marking process. And traceback accuracy depends upon the number of marked packets received by the victim nodes. So then there is another category of schemes that have been proposed, which are log-based schemes. And these log-based schemes, so in the earlier scheme, which was packet marking based schemes, the router, they are storing the information regarding the router or the devices which are there onto the path. They are storing their information to the packets which are traveling. Here, the information regarding the packet is stored in the storage space which is there in the intermediate router. So either there is a centralized server, so the router, it grabs this information and sends to the centralized server, or it can be a distributed approach where it may be some fields of the IP header, or it may be the packet digest, which is stored either onto this centralized server or maybe into the storage space of the intermediate routers. Then the attack path is reconstructed by sequentially sending query to upstream routers hop by hop in a reverse path direction. So suppose in this case, if we are using this log-based schemes, then if this particular machine finds that some attack is happening, then it will send the information to R7, R5, R6, and R8, and in order to check that from where this packet is coming. And because these routers, they have stored the information about the packets that have passed through these routers, so they can actually decide that whether this packet R7 has sent, or R5 has sent, or R6 has sent, and R8 has sent. And depending upon, say, if RS6 finds that I have sent this packet, so then it talks with upstream routers, maybe R2, and if some other router is also connected to R6, to that router in order to find out. So ultimately, this is how the complete path is traced back. So we actually worked on finding out or locating the machines which are hidden behind the NAT device. So because what is the job of the network address translator and why it is used? Generally, when we are talking about IPv4 protocol, then there are two major problems that we need to address. One is that IPv4 addresses are 32-bit. Then when this scheme was proposed, there were classes, and the designers, they said that, okay, class D can be used only for multicast addresses. Then some of the addresses, they are reserved for multicast and broadcast. So not all 2 to the power 32 addresses, they can be used. And even if you can use all 2 to the power 32 addresses, and if the number of machines which are connected to internet is more than that, then what to do? Scaling and routing is another issue, which we'll not talk about at present. But in order to handle this problem, many short-term solutions were proposed. Now the long-term solution is obviously IPv6. But many short-term solutions were proposed, like classless inter-domain routing, and one solution is NAT, which allows address reuse. So what we do in case of NAT, or how the NAT it tries to solve this problem, these addresses, IPv4 addresses, now they are divided into two categories. We have private addresses, private IPv4 addresses, and we have public IPv4 addresses. So the routers or the switches or the devices which are there onto the internet, they only recognize these public IPv4 addresses. So they do the routing using these public IPv4 addresses. And these private addresses, say, for example, these are the ranges from class A, class B, and class C. So the addresses in this range, they can be used as private addresses inside a network. So IIT Roorkee, for building its own network, can assign the addresses into these range to the machines Then if IIT Delhi or NIT Jalandhar is there, NIT Jalandhar can reuse these addresses. But when the machine will send a packet and say if the IP address of the machine assigned to the machine is 172.16.8.9, it will put this IP address into the packet. Now, if the packet actually goes onto the internet with this source IP address, none of the router is going to actually recognize that what this IP address is. So there is NAT in between, and what the NAT it does, so if NIT Jalandhar or IIT Roorkee, it has some public IP addresses, which it should have, so it should acquire some public IP addresses. So it changes this private IP addresses, which is there into the packet, to a public IP address, which is recognizable onto the internet. So I'll not go into the details of all this. I'll just take an example to show. So these NATs, they can be divided into many different categories, and the two main categories are the basic NAT, where we do one-to-one mapping. So one private IP address is mapped to a single public IP address. The other is where we do many-to-one mapping. So if public IPv4 address, so IIT Roorkee, it has say only 128 or 256 public IP addresses, and there are 10,000 machines. So when these machines, they are sending packets outside, then there are many IP addresses that will be mapped to only one public IP address. So then the question comes that when the reply comes back, how the NAT device will decide at the boundary of the IIT Roorkee network, will decide that to which machine this packet belongs to. So for that, actually it uses ports also, port numbers which are there into the packet. So for example, we have a NAT device which maintains a NAT translation table. We have these machines inside the private network with these IP addresses. This router in between on which the NAT device is there, it has two interfaces. One is this and the another is this. So when this machine, it sends a packet, it puts the source IP address as 10.0.0.1, which is the IP address of this machine. And this is a private IP address. So if the packet with this source IP address, it goes out onto the internet, the routers will simply drop this packet. So port number is 3345. So what the NAT it does, it actually puts another IP address into this, which is a public IP address, and puts another port number onto this, 5001. So now you can see that both the IP address and the port numbers, they have changed. Though the RFC suggests that the NAT devices, they should not change the port number unless and until it is very much needed. So for example, what the NAT device will try to do in most of the cases, that if the port number is 3345 and up till now this port number 3345 has not been used, it is not there into the NAT translation table, so it will try to assign this 3345 only, but it may change this also. So here the port number has also been changed, so the packet goes out with this IP address and this port number. When the reply comes back, in the reply, the destination IP address is this, which is this source IP address, and the port number is 5001, which is this port number. So the NAT device, it looks up this table and changes this pair to this pair. So when it sends the packet to the machine, it changes the IP address from 138.76.29.7 to this 10.0.0.1, which is the IP address of this machine, and changes the port number from 5001 to 3345. So as you can see that when the packet goes out, and say if I have installed a traffic capture device here, I'm capturing the traffic here, what the source IP address that I will get will be 138.76.29.7 and not the source IP address as 10.0.0.1. And it may happen that the NAT device has assigned this public IP address to this device also and to this device also. Then how to find out that this attack packet was actually generated from this device and not from this device and not from this device? So this becomes an issue. So I'll skip this part. Concerns about the NAT, you can find out that what are the actually problems with using NAT and what are the drawbacks. One of the major drawback is that it violates the layering principle which is there, because now the NAT device which is at layer 3 is checking the header of layer 4 also. So it is not only using the IP address, it is using the port number, where IP address it belongs to layer 3 and port number it belongs to layer 4. So generally the layering principle, it says that layer 3 should not be aware of that what layer 4 is doing, and layer 4 should not be aware of that what layer 3 is doing. But anyway, so the question is that how to identify the source. So when the source of interest, they are deployed behind the NAT gateways together with many other machines which are actually not of interest, it becomes very difficult to identify the source of interest. And in fact, we have also not achieved this objective to identify the actual machine, but in many cases, we only want to count the number of machines which are behind a NAT device, or we want to identify the traffic only generated by a malicious host behind a NAT. So we have worked on this, counting the hosts behind the NAT, and generally the motivation behind this is counting of hosts present behind NAT. It is important when ISPs, they want to have information about that how many number of PCs connected to the internet using a single IP address. So probably the ISP has put a limit, so wants to check on this. Or say suppose if you are using, in case of a streaming server, as a single client, because it can overwhelm a server by creating large number of RTSP connections, which may deny service to other users using the same server. So in those cases, the other party or the ISP may be interested in finding out that how many devices which are behind the NAT So for source identification, both attribution-based methods and non-attribution-based methods, they have been proposed into the literature. And as I said that, in fact, we have worked on both, but I'll mainly focus on the attribution-based methods that we have used. So network communication is generally described in terms of OSI model, which in which the layering principle was proposed, which was being later adopted by TCP/IP protocol suite also, which we use onto the internet. So it breaks the protocols into distinct layers. So as the idea is that every layer, it provides certain services to the upper layers, and layer I doesn't know that, layer I+1 doesn't know that how layer I is providing these services. So it only knows that, okay, layer I provides these services. So at any time in layer I, we can change the way these services are provided. So we can change the implementation as long as the services which layer I is providing to layer I+1 is exactly the same. So in order to do this, and because these the protocols of layer I, they communicate with the protocols of layer I on the other machine. So how they communicate? They communicate by putting some information into the header corresponding to that particular layer. So these headers, they have several fields. So each layer, it can introduce unique artifacts which can be used to attribute the traffic to a specific source. So we can find out that how a particular information is stored into a particular field of the header of a protocol, and based upon that we can try to find out that the packet is coming from which particular machine. So we used this setup in our lab where there were around 20 machines, 10 machines on which the Linux was installed and 10 machines on which the Windows operating system was installed. Then this is the NAT gateway, a switch was there on which was doing the job which the NAT does. And then we installed a traffic capturing system here. So in attribution-based methods, as I said, that what we did, we use certain attributes, or rather the information which is there into different fields of the protocol headers. So any attribute, the attribute is a property which defines an entity uniquely by its characteristics. So for example, when you want to tell that, okay, he is Manoj Mishra, so instead of telling that, you can say that is Manoj Mishra, this is the, we are interested in a person with this height, with this weight, with this color of hairs, and probably based upon those characteristics, the other can identify that which person we are interested in. So on internet also, these unique attributes, they can be used to distinguish one source from the other source. So the question comes that what these attributes they are. So basically, as I said, that we used attributes belonging to 3 different protocols: the IP protocol, the TCP protocol, and the HTTP protocol. So in attribution-based methods, based upon these attributes, we are trying to recognize that from which machine or from which set of machines the traffic is coming. So when you are using NAT, then a stream, it can be identified by this 6-tuple. So you can loosely refer this 6-tuple, or you can identify a stream by this, which is the source address and source port that has been assigned by the actual source machine. Then because the NAT device has changed this, so we have a gateway address and a gateway port. Gateway address and gateway port, and then we have a destination address and destination port. So source address and source port, they are non-observable properties. When we are capturing the traffic here, NAT has already changed the source IP address and port. So we cannot observe that what source IP address and source port is. What we can observe is only the gateway address, gateway port, the destination address, and the destination port. So a stream is a set of packets. So we can group the packets with the same gateway address, gateway port, and destination address and destination port into a stream. So this is the set of packets with this pair and this pair, and then we can assign these streams to a particular machine, or we can try to identify, or we can try to assign these streams. So source, we can say that it is a set of streams. So a stream is a set of packets and source is a set of streams. So now our job is, when we have these packets, to identify that which packet it belongs to a particular stream and which stream it belongs to a particular source. So objective is to choose an optimal assignment of streams to a particular host. So we can change this problem to basically a problem where we are trying to either maximize or minimize or satisfy some objective function. That is what the optimization problems they are. So we can say that, okay, whenever we are assigning a particular stream to a particular source, either the energy increases or the energy decreases. If the energy increases, we have assigned a wrong stream to the source. If the energy decreases or it doesn't changes, then we have assigned the right stream to the source. So using this method, we can change this to an optimization problem. Yeah. So what is there in optimization problem? As I said, that you have a criteria function, which either you have to maximize or you have to minimize or you have to satisfy. Then there are a set of constraints. So here also what we are doing, we are defining the energy of the system as the sum of energy factors of each source. And whenever we are assigning a stream to a particular source, the energy changes. And our objective is to minimize the total energy of the system. So we are taking a set of streams. So let there be n total number of distinct streams, and let there be total number of n number of sources. And in fact, this n is not known. This n is known. This is the number of packets that we have captured. Yeah. So what we are doing, we are calculating the energy whenever we are assigning a stream to a particular source, and then we are selecting the source which is producing the least energy, so in which the least amount of energy which is changing, and then we are repeating this. So suppose we have, at present I know that there are two sources, S1 and S2, and there are three streams that we have to assign to these two sources. So as I said, that n is unknown and this small n is known, so we know the number of packets, we don't know the number of sources. Now this example, it shows that we are assigning a stream S1 to source capital S1 and to source S2, and then we are changing that what the energy becomes, and then we are choosing the minimum energy. So if EP1 is minimum, then we are assigning this stream S1 to this source. So suppose this n is unknown, so how we handle this problem? So whenever we are assigning these streams to source S1 and S2, we assume that there is some source S3 also. So we are calculating the energy by assigning to some unknown source also, and we are checking that whether the energy change is minimum in case when we are assigning this stream S1 to source S1, or we are assigning stream to source S2, or we are assigning a stream to some unknown source S3, which we still don't know. And if the assignment to source S3, it gives us minimum change into the energy, then we are saying that there is no hope. There is one more host behind the NAT. So there are not only two hosts behind the NAT, there are three hosts behind the NAT. So the same we can do with the stream S2 also, and the same we can do with the stream S3 also. We can assign this S2 to these hosts, and we can assign S3 to these hosts, and we can see that in which case the change in energy is minimum. So how to then describe that what this energy is? So obviously it will depend upon that which field we are interested in. So let us talk about the IP protocol first. We used IP-ID field. It has been used by many other researchers. So the identification field, as I said, that this IP-ID field, it should be unique within the source address, destination address, and protocol tuple when the fragmentation is possible. Otherwise, it is generally of no use, but RFC also suggests that it can be used for detecting and removing duplicate datagrams. But many operating systems, what they do, if fragmentation is not there, they will set this IP-ID field to equal to 0. So suppose if this IP-ID field is in use, so these, and say if the operating system is assigning, because RFC only says this. RFC says, and why we are, these attributes, they are unique, because like as in this case, you can see that RFC only says that IP-ID should be unique. It doesn't say that how these IP-IDs they should be assigned to so that they are unique. So different operating systems, they can choose different ways of assigning these IP-IDs as long as they are unique. So for example, one operating system may say that I'm assigning these IP IDs sequentially. So if to one packet I have assigned the IP ID as PJ, to another packet I will assign IP ID as, so if this IP ID is 1000, to the other packet I will give the IP ID as 1001, to the next packet I will give IP ID as 1002. So then we can define the energy as the IP ID of the j plus 1th packet minus the IP ID of jth packet minus 1. So suppose if the IP ID of jth packet is 1000 and the IP ID of j plus 1th packet is 1001, then this Pj plus 1 minus Pj minus 1 will be 0. So change in energy is 0. M is used in order to handle the width of the IP ID field. So for example, if the width is 8 bits, so the maximum number can be 255. So after that, again the next IP ID will be 0. So then it will be 0 minus 255 minus 1 mod 256, which again gives you 0. So it has been shown, and we actually also performed experiments, and we found that on Windows machine, these IP IDs, they are assigned sequentially to the packets. Whereas on Linux machine, these IP IDs, they are assigned randomly. So though Linux also ensures that these IP IDs are unique, but the IP IDs in case of a Linux machine, they are not assigned sequentially. But here in case of Windows machines, so if we are plotting these IP IDs of different packets, you can see the 2 lines here, which tells that actually there are 2 window machines into the network. Similarly, if we are looking at the IP TTL field and TCP window size field, you can see that different operating system, they use different initial TTL values and initial window size fields. So TTL belongs to IP and this window size belongs to TCP. So in case of Linux, the initial value of TTL is 64. In case of window NT, the initial value is 128. Window size in case of Linux, the initial value is 5840. In case of Windows NT, it is 16384. So suppose if I'm getting a packet, I've captured a TCP packet, and the IP header, it tells that when the TCP connection establishment was taking place, then the TTL field that was being assigned by this machine is 64 and the window size which was being negotiated was 5840. Then I know that this is a Linux machine and it is not a Windows machine, or it is not a Solaris machine, or it is not a Cisco router. So using these properties, again, we can identify that. So in fact, we are not actually identifying the machine, we are only identifying that which operating system it is using. But then depending upon the operating system, you can, so if there are 1000 machines, I can actually tell, at least I can tell that out of these 1000 machines, 600 are using Linux and 400 they are using Windows. And then based upon other features, we can further segregate them. So then on Linux, we used the timestamp value, TCP timestamp value. So the TCP timestamp option, it actually carries 2 4-byte stamped fields. One of them is TSVal. So actually one of the timestamp is the timestamp when the machine is sending the packet, and another timestamp is only valid when ACK flag is set. So it has been shown in the literature that this is a very reliable attribute, at least in case of Linux, for source identification. So by default on Windows, this field is off, but on Linux machine, by default, this field is on. So if it is a Linux machine, it always sends the timestamp value. And this TS value is calculated using this linear function, A.S plus B. So S is the time and B is some initial value. So initially, when the system boots, OS resets the value of TSVal to 0. And then it keeps on increasing. And how it increases, it depends upon this slope A. So A is the slope, and this is OS implementation specific. RFC only says that A should be between, if I remember correctly, between 0.0001 and 1. So then different operating systems, they can use any value between this range. And in fact, different Linux machine, they can use different values of A. So just by plotting these values, I can find out that how many Linux machines they are there. So when we perform these experiments, so we found, so when we plotted these timestamp values, it says that there are 1, 2, 3, 4, 5, 6, 7, 8 machines. Actually, there were 10 machines. So it's not 100% accurate. And that is basically maybe because some of the packets are lost, or maybe some of other reasons may be there. So, but it tells, 9. So instead of 10, it tells that there are 9 machines. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can get an idea that how many machines are there. Then obviously you have other features also, and based upon that you can improve. This is not the only feature which is available for use and for identifying that how many machines are there. So we also used some HTTP features. So what the HTTP protocol it does, whenever say a client machine, say you are accessing some website using your browser, it sends a HTTP request and receives an HTTP response. HTTP request line, it contains a method, a URL, a version. So you can see this example, it contains method get, and then this URL can be a file name also. It depends upon which method you are using. So then it tells that we are interested in this particular page, in this particular directory. So we are interested in this particular page in this directory, and the version of HTTP is 1.1. Then it contains a set of lines which are header lines, which gives you the header field name and its value. So for example, here you can see that we have 4 header lines: host, which is the domain name of the machine that we are contacting. It tells connection should be closed after this transaction is over, or rather this interaction is over. So then user agent, so it tells that this is the browser. So now you can see that we can get the information regarding the browser also if we are using user agent field. So it may happen that there are 100 Linux machine, and on some of the machines we are using Mozilla, on some other machines we are using Bing, on some other machines we are using some other user agent for accessing the web. So you can further divide these machines that, okay, out of these 100 machines, these are the 10 machines which are using Mozilla, these are the 10 machines which are using some other browser, say Bing or some other browser, and then you can find out that, okay, the traffic is coming from a machine, the malicious traffic is coming from a machine which has Linux operating system, and the machine is using Mozilla. So at least now I've reduced the choice from 1000 to 10 machines. And it tells that the accepted language is French. So this is the list of some of the fields into the HTTP header. And in fact, we use this user agent field, which gives the information about the browser and sometimes about the platforms also. And we use this cookie field, and we use this referrer field. So let us see that what this cookie field and referrer field they do. So HTTP is actually stateless. So these cookies, they are used to maintain the state. So when a browser is seeing a website, and the website, if the website is using cookies, it sends the cookie which is stored on your machine, and later on when the browser sends any other request, it sends this cookie into it. So when you are capturing this information, if we can find out these cookies, we can identify that, okay, these 2 or 3 packets or this set of n packets, they are coming from the same machines because the cookie is same. So there is one of the field that we use. Then we use another field which is HTTP referrer, which actually what it does, say, suppose if you're accessing a page, in that page, in order to display that page, it may happen that your browser has to fetch some images which are on some other sites. There may be certain links which a person may visit on when it is clicking on this link. So whenever we are doing this, so when the browser sends another query, say for example in this case for image1.jpg, because this image belongs to this particular page which was accessed by the browser, so this information, it goes into the referrer field. And similarly, when say if on this particular page this link is there to page1.html, so when the request goes for page1.html, this information goes into the referrer field. So now we can link all these queries or all these packets. So if the packet says, one packet says that it is trying to access this particular website, www.example.com. Another packet, it is trying to actually get image1.jpg, but the referrer field says that this actually request has been originated because this particular website was accessed. So we can link the two packets. We can say that the two packets, they are coming from the same machine. So this is how the referrer field can be used in order to identify that, or in order to group the packets, or in order to group rather the streams and the packets, and we can identify that to which particular host they belong. So other than this cookie and referrer field, as I said that we used users in field, timestamp and clock, login ID, email address, chats, proprietary protocols, we have not used, but they have been used in other works. So the people, they have used these timestamps, they have used login IDs, email addresses, chats into the payload. So actually the payload was examined and this information was extracted from that, whether the machine is using some proprietary protocol or not. So all this information was used in order to identify that which machine or how many machines they are there. So we developed an algorithm to count the number of hosts behind the NAT device. It also classifies the hosts based upon the operating system that has been installed on its machine. And as I said that not only operating system, based upon the user agent which the machine is using. So it tries to group the machines based upon their operating system, their user agents. So this is not our algorithm because the algorithm that we developed based upon these fields that I have just discussed. So we have submitted a paper on that. So this algorithm I'm showing you just as an example which I have taken from some other paper. So what it does, it captures the TCP packets and then checks that whether the packet is, the sync flag is set or not. And if it is there, based upon the TTL field, it tries to find out that whether it is coming from a Windows machine or it is coming from a Linux machine. If it is coming from a Windows machine, then it gets the IP ID field and source port field and the time when the packet was captured. If it is coming from some Linux machine, then it gets the information regarding the TS-val field and the packet arrival time field, and depending upon the IP ID and source port field. So we have classified now the packets into two categories. So if say suppose n number of packets they have been captured, it says that out of these n1 they belong to Windows machine and n2 they belong to Linux machines, where n1 plus n2 is equal to n. But how many Windows machine and how many Linux machines, that we still need to find out. And for that, it uses this IP ID and source port field to find out that how many Windows machines they are there. So we just saw that because Windows machines, they implement these IP IDs sequentially. So by plotting these curves, as I have shown that we can find out that whether, or rather, how many Windows machine they are there. So this work, it uses IP IDs and source port to identify the machines, how many Windows machines, and similarly tsval field to identify that how many Linux machines are there. So in order to determine whether a packet is coming from the same host, it uses certain parameters. Clear? So we use different set of parameters depending upon our experiments. So these parameters, they belong to the work which uses this particular algorithm. So time limit, which tells that if the current packet and the last packet that has been received, the time differs not more than 6 seconds, then it may belong to the same machine. If the port gaps, so if one packet, the port is 4443, another packet, the port is 4444, then probably they may belong to the same machine. Similarly, the IP gap, and based upon these things, it tries to create several lists corresponding to the Windows machines and several lists corresponding to the, so when it is getting a packet from and it identifies that, okay, it belongs to Windows machine, it tries to create list L1, L2, L3, L4, L5, and it assigns packets to these lists, and each list, it belongs to a particular host. Yeah. So 50 is the number. So if any list, if the number of packets, they are lesser than 50, then it says that no, this may not be a new host. So these are some of the parameters that this particular algorithm it uses in order to identify that how many Windows and how many Linux machines they are there. Okay. So that's what's about so then we did some work where we actually used machine learning based techniques for counting hosts behind the NAT, and here we used so basically the sequence of steps that we followed capturing the network traffic. I'll not go into the details of this work, but I'll just give you a brief overview. So we captured the traffic, we extracted the features, then we labeled the data for training purposes, and then we use certain classifiers for the prediction that how many machines are there. So the data sets that we used, so the first data set, it belongs to the ICS lab that contains 16 different users. So these were PCAP files, .pcap files, and the size of the PCAP file was around 200 MB. The second data set that we used was from Western Regional Collegiate Cyber Defense Competition. And this data set, it also contains a set of .pcap files, and the size was around 170 MB. And in that experiment, there were 10 users. Other than using these two data sets, we also used the data set that we captured in our lab. So we used Tranalyzer. So using these files, we gave as an input to this particular tool, which actually gives us flows and the features corresponding to those flows. So Tranalyzer gave us 105 distinct features. So then depending upon their importance, we selected 49 features out of them. And then we used 6 different machine learning classifiers in order to find out that how many machines they are hidden behind the NAT. We actually found that this decision tree and random forest, they gave the best accuracy. So these are some of the features that we used given by the Tranalyzers, like number of Unix source connections, destination port, TCP acknowledgement, trip average time, window scale, and all these things. If you want to know about in details about these features, you can see the tutorial of Tranalyzer, which is available at this particular link. And the file that we used was file actually file name was the file name that we used, underscore flows.txt. It generates many files. So because we were interested only in the features of different flows, so we use this file. So these were the results of our experiments. So we compared our work with these three works, and we found that accuracy in our case was nearly 99%. So these works they use, actually in this work only IP-ID fields has been used for identifying that how many machines are behind the NAT. In this particular work, user agent field has been used. HTTP user agent field has been used. In this work, IP-ID, TTL, source port, timestamp, they all has been used. This is the algorithm that I have shown you. So this is the other work that we are working on in this particular area, which actually belongs to identifying, now the ultimate objective is to identify the source machine from where the attack is taking place or where the crime has happened. But at present, we are working on counting the number of machines which are behind the NAT and then classifying them based upon their operating systems, based upon the browsers or the user agents used by the users when they are working on those machines. So that's all about this particular lecture. So if you have any queries, you can ask. Should I stop? Yes. Should I stop sharing? So thank you all.
Thank you, sir.
Thank you very
Being the
much.
coordinator of this course, I take this opportunity to thank you, sir, for sparing time to be the chief guest and expert speaker for this STC. Your talk on cyber crimes, network forensic, and identification of hosts behind net was fully informative and enlightening. I'm sure that the participant must have taken benefited and hope we all are incorporate your ideas and be cautious while being on cyberspace. Thank you very much, sir.
Thank you. Thank you all.
Thank you, sir.
Thank you. Thank you. So I'm leaving now. Thank you.
Thank you very much, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, participant. We will be having another session that will be start from 3 p.m. and I request all the participants to join 10 minutes prior.
Hello, ma'am, are you there?
Yes.
Yes, good afternoon, ma'am.
Yeah, good afternoon, Rita.
Yes, ma'am, how the attendance is being recorded over here?
Actually, at the end day of our STC, we are just providing you the feedback link. Okay.
Okay.
And based on that, whatever the attendance we are just collected throughout the session, so we just calculate. Okay, and on the basis, the certificate will be issued to you, and it is mandatory for all the participants to maintain the 80% attendance.
Okay, ma'am. Thank you so much.
Thank you, dear.
Ma'am, excuse me. Ma'am.
Yes, sir.
Hello. Ma'am, for this session or evening session will you post that attendance?
All the session, all the 5 days.
No, that's why I'm asking. When finally you will post that feedback or daily you will post the feedback?
Sir, after the end day, last day, that is on 5th September. I'm just giving you the feedback link. Yes, sir.
For this session you are giving?
Yes, sir.
For this session you are going to give?
Yes, sir.
Okay, thank you. But every session we have to fill, right? Every session we have to fill, right?
Your voice is not clear, sir.
No. What I'm asking for every session we have to fill.
No, sir. At the end day, we are just giving you the feedback link. Okay,
Okay,
on the
ma'am.
5th
But what
September,
about this session, ma'am?
It's automatically recorded.
Sir, it is automatically recorded, na?
Okay. So daily we no need to put feedback and all, right?
Yes, sir.
Thank you so much.
Thank you, sir.
Yeah, thank you. Your name, ma'am?
Yeah, in the there we have the another session at 3 p.m. So kindly be there.
Okay, ma'am. Thank you.
Okay, thank you very much.
Okay, thank you.
Hello, madam. Hello.
I think she left.
Yeah, hello, sir.
Oh, yes. Ma'am, I want to ask that if we log into the every week, then our recorded. Yes, sir.
Yes, sir. Yes, sir. We have just recorded. Okay, it is already recorded, so you don't need to worry about that.
Ma'am,
That's why I was asking. Okay, ma'am.
Okay, thank you very much,
Another thing is
participant.
that,
ma'am, I have one last
this
question.
class is not available in the YouTube. It is only available in the Google Meet.
Sir, due to some network problems, I am not able to hear you.
Ma'am, I am asking that this class is available only in the Google Meet, but whenever I am trying to logging on in the YouTube, it is not working.
Yeah, sir, it is working, sir. It is working. Maybe there is some network issues from your side.
Working, no?
Yeah, both are working.
Excuse me, ma'am.
Sir.
It is showing
Now, okay, sir.
different in YouTube. Ma'am.
Okay, sir.
Hello? Yeah, I'm online. I joined. Yes, yes. Yes. Okay.
So, welcome participant in the evening session of the STC on security and privacy challenges in computing paradigms. And it's a great pleasure for me to introduce the expert of this session, Dr. Pilli Imrankar Shubhankar. I wholeheartedly welcome you, sir. Dr. Pilli Imrankar Shubhankar is an associate professor in the Department of Computer Science and Engineering, Malviya National Institute of Technology, Jaipur. He has 21 years of teaching, research and administrative experience. He is senior member of both IEEE and ACM, as well as member of Cloud Computing Innovation Council of India and Forensic Science Work Group on Cloud Computing of the NIST, USA. Dr. Pilli is guiding MTech, 5 MTech and 13 PhD students in security, forensic, cloud computing, big data and IoT. Now I request to Dr. Pilli sir, please join us for a great session.
A very good afternoon, and it's a joy for me to join before you. Of course, I'm not able to see any of you because the whole screen is being covered by my own slide. But anyway, I hope that we will have a beautiful time here in this afternoon, and as we continue to understand security in blockchain. So I'll primarily, you can consider it as blockchain and security, because of course there's a little bit of idea that you will also need to know what is blockchain before we go into understand what is security in blockchain, right? So in order to, so I'll take you through a journey of what is blockchain a little bit, and then we'll move into some of the security issues that can come up. Security per se, if you look at my own journey, I started with network security as my research area, and I did my PhD on network forensics from IIT Roorkee. So at that time, maybe 10 years ago, forensics was a very upcoming field. And of course, still it is, a lot of scope is there. If somebody is interested, you can look at forensics. So when I came out, then I started looking at cloud security and cloud forensics. You can look at that. So that has been my next level of work. Then later I moved into understanding what is big data, then big data security and big data forensics. Then the next level was IoT, IoT security, IoT forensics. And we are moving into now a little bit on blockchain security and maybe security issues, a little bit trying to understand. I've started exploring a little bit on quantum computing, right? So in this aspect, if you look at security or forensics can be applied to any upcoming field. So in fact, some of my colleagues are working on what is called software defined network security issues in SDN, and security issues in network function virtualization, NFV. So you talk about anything. In fact, in between from cloud, I had moved to a little bit on Docker security and Docker forensics. So I want to encourage you, please look at any upcoming field, because there are bound to be security issues. So that can be a motivation. So let us not be afraid of new upcoming fields. So what you need to do is you need to understand how it works. So and one question at the beginning itself, I would like to ask most of you. I have seen most of you are also learned faculty are also there. And some young minds are there, young student minds are also there. So just a point of view, if you ask me, or if I want to ask you, the question is, who would have taught me blockchain? If I'm taking a lecture today, who would have taught me blockchain in that sense? Right? Of course, I'm not expecting an answer because it will be too much of a disturbance. But the point is, you all realize that I would not have studied blockchain in my undergraduation or post-graduation or during PhD also. We did not hear the word blockchain also. It's only a couple of years, 2-3 years onwards, we have been hearing this word blockchain, right? So I have picked it on my own. You have to study and you have to learn, you have to discuss with your students, and maybe you can offer it as a PhD problem, and then we can take it up, right? So that is the thing that is there. So what we try to look at is these are the words when we talk about blockchain. What do you say? A digital coin, or a digital transaction, or a cryptocurrency, or a blockchain, a Bitcoin. You know, these are the words. Payments, protocols, smart contracts. You know, these are the words, right? Virtual money. Right? These are the words that you can come across, right? And then transactions. You know, a variety of words you can look at, right? When you look at. So, what is Bitcoin? If you look at it, it is a cryptocurrency. So it's a blockchain-based cryptocurrency. Now, Bitcoin may not be a very interest for us, but that actually generated the interest in blockchain, because the blockchain came up because of Bitcoin. Right? It was not that blockchain was discussed first and then Bitcoin used blockchain to become popular. No, Bitcoin made blockchain popular. So that is something which we can look at, because a peer-to-peer electronic cash system was discussed by somebody called Satoshi Nakamoto. Right? Of course, we don't know who this Satoshi Nakamoto is, because it's a pseudonym, right? There's no actual person who exists, right? So it is a pseudonym, and like most of the authors have their, pen name, they call it, right? Kalam ka naam, right? So something like that, right? So it is a pseudonym, right? So it is not his actual name, and there is no actual person called Satoshi Nakamoto, right? But in 2008, a paper was written, and this was released into the wild, right? And people started reading it, interesting. It was not published in any journal. It was not. It's just an open source paper which was left out, right? Please go and read if you want to understand the history of blockchain, or where it started and how it started. You can just download this paper, freely available, open source, and nobody owns it, so you can just download it from there. And then Satoshi Nakamoto suggested a peer-to-peer electronic cash system, and later he created a first ever block. We'll understand what is a block and what is the first block is called the Genesis block. Genesis means the first one, the beginning. You can consider the word Genesis talks about beginning things. So that is what you can look at here, right? So this is how it looked like the day of its launch. The Coinbase of Genesis block references a story in Times of London. The Times newspaper came out and he said there's a block 0 and this is how it looks like, right? And then what it actually means is you can try to look at how it is, right? So it has the libertarian roots. Okay, that's what they talked about, libertarian, in the sense you don't have to actually look at a banking system now. It's a public banking system, that's where the word ledger comes up. It's a public ledger system. Blockchain is a public ledger system. Now, what is a public ledger? Okay, maybe this generation, maybe 2010 onwards, you may not have heard of what is a ledger. You would not have seen a ledger, maybe, right? When you went to banks in couple of years ago, banks used to have ledgers. For every account, there used to be an entry in the bank, a page in the bank, right? And in the page, the clerk used to make an entry that so much money was deposited or so much money was withdrawn, right? Now, of course, because of the online transactions, everything is going online, and you don't actually now you don't enter on a paper. paper, right? It is all digitally stored somewhere, right? So that ledger, earlier it was a physical ledger which was securely kept and nobody could access it. Only the person who was sitting on the counter could access it. The consumers can never look at it. They used to have a passbook. So if you want to have a copy of your own ledger of that account, of that page of your account, you could get a passbook printout, right? Printout of your own passbook, right? And now, of course, it's online. You can view your own ledger. Now, the beauty of what a public ledger is, public ledger, everybody's account's ledger is on the open. Anybody can view the ledgers, right? And then now you will be surprised. अरे सर क्या हो रहा है? मतलब मैं किसी और का पैसे भी देख सकता हूँ? Can I look at somebody else's bank balance? Yes, I would say yes. You can look at somebody else's bank balance as far as Bitcoin transactions are concerned, as far as the number of Bitcoins they hold is concerned. Sir, then what is the so advantage? The advantage is that you don't know whose account it is. You don't know whose account it is. Wonderful. You know, you only know that there is an account and there is so much money. Everybody's accounts are displayed openly, anybody can see, but nobody will know whose account it is. And if you want to transfer the money to somebody, and people will have to share what is called a hash value. We will just shortly look at what those are and how it looks like, right? So using an address, you can send money from one person to another person. So when you open a Bitcoin account, right, you will have your own address, and using that address you have to send. It's very difficult to find out and correlate whose address is whom, right? We don't know who the person is, right? And there is no way anybody can know that, right? But then the ledger can be very easily open and checked by anybody. Here is one such thing, the Genesis block. You can see it. There is a short link given there, blockexplorer.com. So you can go to blockexplorer.com and see the whole block, right? So that is something. Yeah, anyway, in a couple of slides, you will understand, right? So as of this year, there are about 100,000 merchants and vendors accept Bitcoin as a payment, right? Earlier, Bitcoin was not accepted. Bitcoin was not considered a safe currency, but 100,000 merchants now. That's very good, and a lot of these accept, right? But it is based on solving an encryption formula, which now requires extreme amounts of computing power. Bitcoin is based on solving an encryption formula, and each time you solve the formula, you earn some Bitcoins. And this is a typical situation. If I solve a problem, how do I earn Bitcoins? Now, there are no such thing called Bitcoins which are created. It is like a reserve bank. Now, you may also have a wonderful question. Okay, why not India print as many rupee notes that they want, and they just distribute? You know, they don't distribute. They don't allow that, right? The RBI will allow, or the Reserve Bank of India will allow only a certain number of notes to be printed, right? And in fact, we all have gone through this a big exercise of what is called demonetization, right? Demonetization happened, and they declared the 1,000 rupee note as invalid. They say it is not a legal tender. It is not a legal tender. Legal tender, because now you have a 500 rupee note, it is legal tender. Now you have a 2,000 rupee note, it is a legal tender. But if you say I have a 1,000 rupee note, people will laugh at you, because now the 1,000 rupee note doesn't exist anymore, right? But of course, there are a variety of denominations which have come in. You have got a 200 rupee note now, right, which is a legal tender, right? So these are the things which are going to happen. So the government, if somebody has a problem that I have this note and somebody is not honoring it, you can go to the bank, the Reserve Bank, and the Reserve Bank will say, no, this is a legal tender, aapko lena hi padega, right? Something like that. You have to honor it, right? So there is a bank which supports this currency. Bitcoins, there is no bank, right? So when there is no bank, who creates these Bitcoins? That's a beautiful question. There is an encryption problem which is mentioned in Satoshi's paper, Nakamoto's paper, right? And he says you can solve this and earn Bitcoins, right? And then Bitcoin started being given to people, and people can transact using Bitcoins. People can buy things using Bitcoins and all that. So maybe in the whole world, about 21 million Bitcoins can be created. So it also is a prediction based on the cryptographic code that has been written, and almost 80% of Bitcoins have been mined, right? 80% of Bitcoins, the puzzles have been solved. That is what you can try to understand, and we'll try to understand how it goes. So now if you want to get some Bitcoins, what you can do is you can go to a Bitcoin exchange, And surprisingly, I'm sitting in Jaipur, and one day the Doordarshan invited me to speak on Bitcoin. So I was speaking on Bitcoins, and a gentleman next to me in the panel, he was also sitting there, and I was amazed to realize that there was a Bitcoin exchange in Jaipur. Right, he was a man who was holding it, and he was encouraging the use of Bitcoin. I was telling the pitfalls of Bitcoin. The problem may come. As of now, it is used like a stock commodity. You buy a Bitcoin, the money will increase. You can sell it back when you need money. So in between, you would have made a lot of money. Okay, that's one aspect of it. But suddenly, if the Bitcoin code crashes, then nobody will give you back that money. You may have 1,000 Bitcoins, it's going to be zero, right? But you can have the transaction from your friend. You can create your own Bitcoin wallet, and then you can say, friend, this is my address, please send it money to me, send a Bitcoin to me. He can send it if he has a Bitcoin, right? And you can create a Bitcoin by mining. Mining is, some of these, you can create, because now 6 and 6.25 Bitcoins are issued as a reward when you create a block. It is halved every few months, right? So May 2020, it became 6.25. When I started talking about Bitcoins, it was 25 Bitcoins were given. They later became 12.5 Bitcoins. Now it has become 6/1/4 of a Bitcoin. It was done in May 2020. So the next time it will become 3.125, right? 3.125 Bitcoins. Maybe another 1 year later, it will become something like that, right? So the open ledger that I was talking about, this is a live snapshot taken from blockchain.info or blockexplorer.com, right? You have seen these addresses here. You can go to these addresses. You can see the latest created Bitcoin. It was, I think, yesterday's or day before yesterday's. I was preparing this slide, so I took a snapshot. So you can see that this was about evening 7:30 when this snapshot was taken on 20th. So the current blockchain which was added, the block number is 646148, right? 6 lakh blocks have been added. 6,46,148 blocks have been created. And who created that? So I will come to this word. What are these pools, right? So a little later, but these are the person who created this block was the mining pool which has mined this block, right? And the number of transactions which are added into the block. Every block will have some transactions. So size of the block, in bytes. So it is always less than 1 MB, and the time at which it was created. And once the block was created, 6.25 Bitcoins are given as a reward, right? So there are some transaction fee which is taken, and then you get that money, right? So that is what actually happens when you look at a Bitcoin ledger. You can see the ledger, it is open. Who creates a blockchain will be seen there. And this is how it looks like. Your blockchain address, your block address, a particular block's address will be a big number like this, right? But there will be 19 preceding zeros, right? It is based on the number of zeros are depending on the level of difficulty of block mining. I will take you to that a little bit later, right? And these confirmations is an important word. Number of confirmations is 1. Number of blocks added referring to these blocks. After this block, 1 block was added to this chain, right? So number of transactions included, 600 transactions were included in 1 block, right? And the level of difficulty is mentioned here. Hash of the next block that refers to it is mentioned here. The previous block is mentioned here. So the block, a particular block, if you click on a particular block, there is a next block that is there, and the previous block and the present block, and you have these values which are mentioned here, right? So if you look at a ledger and see the transactions, how it happens. So this is a transaction hash, and the input Bitcoin addresses. This is an address where this is usually 31 bits, right? So you have a 31-bit Bitcoin address, and you are sending the amount of Bitcoin. What you can do is a rupee can be split into 100 paisa, and then you have 50 paisa coin. You have used to have 10 paisa coin, like that. Bitcoin can also be split into different denominations. So here you see you can split up into a part of the Bitcoin can also be transacted, and output Bitcoin addresses receiving the Bitcoins. So you are sending these Bitcoins from here, and they are going to these addresses, and finally what is the charge that is involved. Earlier when Bitcoin initially started off, there was no fees, no fees, because now when I want to transfer money, some money from America to India or from India to some other country, I have to pay a transaction fee to the bank, right? In fact, when I transfer money from Jaipur to Jalandhar also, the bank will take some money. If I want to send 5,000 rupees, it may take some 50 rupees, right? As a what do you say, the DD fee or something, right? Here a DD is made, then it is given to you and you post it, and the person receives the DD on the other side and he encashes, he gets 5,000. But you will have to pay 5,050 rupees or 5,070 rupees, right? That 70 rupees is the transaction fee. So Bitcoin was actually tried to create that there should not be any transaction fee. So that was the initial step that was there. So Bitcoin is actually gaining value, and a lot of people have started using Bitcoin. And but the idea of why Bitcoin was being used, the Bitcoin was being used because maybe if you look at some of these aspects here, a Silk Road was created, an anonymous market is created, right? It is called the eBay of drugs. And then you use what is called torrents or Tor, the onion routing network, Tor network, and then you can use. So it's kind of drug abuse material and narcotics and any of these, or maybe porn content. All these things are sold, and where nobody wants to have a transaction using a bank account. Right, so you can very easily make a transaction. So that was what the thing. And in December 2017, if you remember, Bitcoin price was about 13 lakhs, and presently today the Bitcoin cost is 8 lakhs, as you see here. So this was about 13 lakhs. There was a big spike here in December 2017, and a lot of people were interested, and a lot of people started working. Right, so maybe at that time itself, I also started having an interest on Bitcoin, and I started doing that. And presently, it is now placed at about the August first week. If you look at, and August 26th today, it is around $11,690. That is roughly 8.5 lakhs, right? So presently, one Bitcoin, if you have had, it is 8.5 lakh rupees. You can sell this and get money in Indian currency. That is possible using a Bitcoin exchange, and you can do that. And of course, after Bitcoin, there are so many coins which came up, called the Ethereum, the Litecoin, the Zcash, the Ripple, Dash, and our own Desi version, you can call it the Lakshmi coin. So a variety of coins have come in. Now, why do you think Bitcoin matters? Why do we have to study? Why do we have to understand, right? It's basically an interest for computer science people, because it involves what is called cryptocurrency. It involves cryptography. And if you feel cryptography is computer science, then Bitcoin should matter to you, right? And it is a cryptocurrency. It is purely digital. It is not controlled by any central entity. If you say, I have 1,000 Bitcoins and this is the money I have, any day the Bitcoin blockchain software crashes, okay, then your all money is zero, because there is no agency which will enforce and say, okay, you bring back all those notes to us, we will give you the money. Nobody will say that. In case of RBI, RBI will do that. If suddenly there's a problem with some things, they said, give us all back those 1,000 rupee notes, we will give you back 100 rupee notes or 500 rupee notes, don't worry. That was what they did. But there is no centralized agency in this case, right? And it solves this double spending issue also. I cannot make two transactions using a same Bitcoin. It is not allowed. We will discuss that a little bit later, right? So the peer-to-peer network, in which transactions directly between users, no intermediary. But earlier it was free. There was no transaction money charged. Now there is a token transaction money which is charged. Otherwise, you cannot survive. Nobody will be interested to solve the Bitcoin. Nobody will mine the Bitcoins, and nobody will continue the Bitcoin transactions, right? And transactions are verified by network users. Few volunteers are there. I am amazed at these set of volunteers, because they are the people who are mining the blocks. They are the people who are adding these transactions. They are the people who are verifying these transactions. Now, what are they getting? They are getting Bitcoins as a reward. And what is happening? They are taking those Bitcoins and converting them into converting them into any of their own currencies. And because most of the countries have blockchain exchanges or Bitcoin exchanges, which will give you that money, right? So the transactions are recorded as block in a public ledger called blockchain. Now, what is a blockchain? This is where our interest starts. Till now, it was just to create an interest into what is a Bitcoin and how the Bitcoins have come in. It is because of the concept called blockchain. Now, what is a blockchain? It is a method of storing data among multiple parties that ensures data integrity. Trust is created. Amazing. And trust is not broken till now. So many years now since Satoshi Nakamoto has started his blockchain, it's running, and 6,50,000 blocks have been created, and it is still going strong, and people are working, and pools of people are working to create blocks and add it to the blockchain. Okay, it's a distributed ledger or a shared database. It's a simple shared database. I'll show you diagrammatically. One of the best application was created to explain blockchain. So I'll show you that, and that's where once I was interested, I looked at that application. In fact, it was a video. I will encourage you to look at that video. But once I saw the video, then I understood very easily, and I am going to share that to you also. Of course, not the video, but the actual how it works, right? So everyone holds a copy of the entire logged history of transactions. So what I was talking about, in the bank, there used to be a ledger book having the details of all the accounts. If there were 1,000 accounts in a bank, 100 or 200 accounts were put in one ledger. So all that big set of ledger books were there, and all of that could have the details of all the accounts. What is the amount that is there? Now, all these accounts are open or public. So that is what. So if I create a blockchain for myself, or if I want to create a block, so what I have to do is first download the entire blockchain, right, and keep it with me. And if I want to see the transactions, I can see the transactions of anybody. But the problem is I will not know who that anybody is. That's the only thing. And it is immutable. The word immutable is never changing. So once a transaction has been approved, you cannot change it. So that is what it is very important. And then it is timestamp. Nobody can deny it, and nobody can say. So same is the case in the bank. What used to happen? They used to put a date, and they used to say the money. So now the accountant would do that. A user cannot come and say, sir, I deposited 1,000 rupees, and he is my bank account should have. They open the ledger and see on this day no amount was deposited, and hence the money is not there. Matter closed. They won't listen to any of your words, because they say if you have deposited the money, he would have made an entry, and if the entry is not there, you have not deposited the money. So because it is time stamped. So in a similar case, it is digitally time stamped here, and change cannot happen. So this is how the blockchain concepts are. So this is what I was talking about, this Anders Brown Worth. The very, very interesting website. And then you can look at Blockchain 101 in YouTube, a very wonderful video. You can look at that and how he explains this. So this is how he starts with this SHA 256. So first thing that is needed is hashing. Of course, the time that is allotted to me will not allow me to go into the details of hashing, but you all have studied hashing. This hashing will take some time, and of course you know what is hashing. And there are different secure hashing algorithms. So we have this SHA 256 algorithm, which is used in the blockchain to create a hash. So here hash is introduced. So I'll show you how it changes as we keep changing different words. So a blockchain will look like this. Blockchain will have a block header and a list of transactions. I showed you in the Explorer, the Hyperledger public ledger. I've shown you that there are some transaction lists which are made. So each block contains the cryptographic hash of the previous block, timestamp, and the transaction data. And this block's hash address, okay, it is connected to the previous block. Every previous block's this header is stored here, this address information is here, and a list of transactions. This address information is here, this address information is here, and a list of transactions. And then when you add the next block, this block address must come, some transactions will come, and the new block header will be added. So this is how it goes on, right? So a block header will look like this. There will be a previous block hash, there will be a nonce, and there will be a Merkle root, right? So these are some things which are there. So we will try to look at, if I want to create the hash, I will use the previous block hash, I will have a Merkle root value, and I will have a nonce. I combine all of these and create a hash. The block ID will be hash of the block header. So the block header will be like this, and when you take a hash of that, you will get a block ID, right? So this is how a block looks like, right? So this is how the block looks like, and this is how the transactions looks like, and this is how the hash looks like. So the block number, this is the block number. How is the block number? Block number is there. Then you have a nonce value, and then you have a list of transactions which I want to approve. Then you have to create a hash value. And here you see, as a sample example, we have created only this first 4 to be zeros, right? Actually, I have shown you in that previous block explorer slide. You would have seen that there are starting 19 zeros. This is a snapshot which I want to show you. So let me take you through these concepts once, and let me take you through this Anders Brown work, this website, and then let us come back, right? So
Sorry to interrupt you, sir.
yeah.
Sir, could you please explain what is nonce value in that header block? I'm not
Yeah, I'm
able
coming.
to get it.
Yeah, sure.
Okay.
Are you able to see this site here? Blockchain demo.
Yes, sir.
SHA 256 hash you are able to see? No?
Yes, sir, it's visible.
Yes, sir.
Yes, sir, it's visible.
Not now, sir.
Yeah. Visible now?
Yeah.
Yes, sir. Yeah. So you just first let's follow. This is a blockchain demo here, and we are going to see what is a hash, what is a block, what is a blockchain, what is a distributed blockchain, and what are the tokens, what is a Coinbase, right? Now, just we are trying to introduce you what is SHA 256 hash. So there is no value here, but you have created a hash. So if I say hello, just imagine every word, everything I type, right? If I'm typing H, can you see notice the change here? Please notice the change here, right? Maybe I will increase the size a little bit here. Right? Are you able to see that? So if I remove this H, the hash value will be something different, right? It will be the same each time. If you remember, if I add E, it'll have this value. If I remove that, the hash value will be same, right? So a particular hash value will keep coming, right? Or if I type blockchain, so it will be changing, right? So as I keep typing the text, the hash value will keep changing. This is the first level of thing. So what is a hash? Now let us come to the next step. I am talking about a block. What is a block, right? When I talk about what is a block, okay, the block will look something like this, right? There is a block number and there is a nonce. Now this is what is the question, right? I'm just coming to answer this nonce, right? Then there is a hash value. Right, the hash value here in this example, because this is a sample blockchain that we have created, we are using only 4 zeros at the beginning. The actual blockchain uses 19 zeros, and sometimes it varies depending on the time. Okay, so what you have to do is you have to fulfill this, and then you can add some data. Right, let us say now I add data. Okay, now once I add some data, what has happened? The color of this has changed from green to pink. That means this data has invalidated. Why it has invalidated? Because the hash is not satisfying the formula. The cryptographic formula says it must start with 4 zeros. Let us simply understand that. Okay, it may not be very, maybe for you, for more understanding, you can go to go and read Satoshi Nakamoto's paper. But here what we are trying to understand is, just I added this, some new transaction here, or made a change to the transaction like this. So then it is okay. But if I add something like this, so the things have changed, the hash has changed, hence it is a problem. So now the problem is, what has happened is the block, a nonce value, the data, and this, it must satisfy. right? Here there must be 4 zeros. So what I can try to do is, I can try to change this nonce value. What I have to do? I have to start from 1. Right? And so what has happened is, I can keep varying these values 1, 2, 3, 4, 5. So whenever that particular value satisfies this hash, which has the first 4 zeros, then you can say that this block is very much accepted, right? So maybe if I add some more data like hello, and let us say we add block here. So once I just pressed a new character, it changed. So again, if I put block, again it does it. So what I do, I have to write a mining algorithm, right? The mining algorithm is, it is going to find a nonce value, right? It is going to have a combination of those 3 values, right? What are the 3 values? The block number, the previous hash value. The previous hash value is included. I will show that later. Okay, and the data. So now what has happened is, what is the mining algorithm is, I have to find a nonce so that the block number, the data, and it will satisfy a hash value. So I have to find a nonce. So what I have to do, I have to start with 1, 2, 3, 4, 5, 6 till what number satisfies. So I have to, each time I have to check whether it is satisfying this hash value or not, right? So what I've done here, behind this button called mine, there is an algorithm for mining algorithm, right? So I will explain that. So that mining algorithm, once I click here, what happens? It goes and finds a nonce, this nonce. This nonce satisfies this hash value, and this data is now authenticated. This is what is a block, right? Now let me take you to the next step, right? That is a blockchain, right? Now what is a blockchain? Blockchain has blocks 1, 2, 3, and so on. So the number of blocks are increasing, right? So they are moving on, and you can see that. And as you keep going to the right hand side, you can keep on adding more and more blocks, right? So let us say, take a sample example here. The Genesis block, obviously the first block, will not have any address, right? So it is not going to have any address. So because the previous address is not there, so only zeros they have put. The next address, the next hash address has these values, which obviously the first 0. Now once I create this blockchain, all of them are in one order, right? But then there is no data. So if I want to add data, let us say transaction 1, somebody wants to send money to somebody, right? I add that transaction, right? Let us say transaction 1. Once I add this transaction 1, now what has happened? This whole blockchain has become invalidated. This whole chain has been invalidated. So what I have to do? I have to mine this value, right? Once I mine this value, I have to ensure this mining is going to, it's not going to affect other blocks again. Only this block can be found. So again, what I have to do? Again, I have to mine. Again, I have to mine. Then this block in. So whatever transactions have been approved, if I want to make a transaction, so I have to keep on making mining on all the blocks. So and hence this is not allowed, right? So once the transactions which are present here are freezed, I cannot change this value. Only I can add a new block which is fulfilling these conditions, that the block header number, the nonce value, the previous hash value will satisfy a present hash value, right? A combination of these 3 should follow, right? And you can read the paper to find out that equation. I will show you in one slide, right? So this is how it is done. Now what is happening is blockchain. Now, sir, it is very easy. Why not change all the blocks? Somebody can attack the blockchain and change all the blocks. Yes, that is the question, where blockchain is not a single chain. Blockchain is a distributed chain like this. Blockchain is a distributed chain like this. What is a distributed chain? Peer A, let us say I will have a chain with me. Somebody, peer B, will have a chain with him. Peer C will have a chain with him. So everybody has the public chain. Everybody has a copy of the chain. So if I want to make a chain, now I have to make a changes in all the chains, which is again not possible. And hence, any change which has recorded and which has been approved in the blockchain cannot be changed. Now you can see that, right? I want to make some change here. So you can make a change here. So what has happened? These have changed, but these have not changed. What is happening? You may add here, and you may say in your own chain, you may make everything clear, right? You can make everything correct, right? So this way, this looks nice. But then you see this is 40456, right? And if you go below, the 40456 is not there. And let us say here, if you see, these two peers will say, "Arey bhai sahab, you have done some golmaal," right? Because our nonce doesn't match your nonce value. Our hash value doesn't match with your hash value, right? So this is how the blockchain is created. And now, if you understand what is the word tokens, these are how the transactions will look like, right? So what has happened? I make all these transactions and I move down. Right now you are saying $25 has been given from Darcy to Bingley. Now I am a clever fellow. I want to make it, let us say $24 only. So what has happened? Once I made a change to the transaction, all these have been failed. So what I have to do? Again, I have to mine all this block and I have to find out the hash value here. Then I have to go and mine and find the hash value here. So what I have to do is, it's very difficult. It will take a lot of time, right? Because the transactions are also included now. See, you finally got the result. So why again? I have to mine this. Then I have to mine this. So this is how it goes on, and hence it is, of course, and then a copy is maintained here. So the copy of these two, peer B and peer C, they say, sir, it is only $25. $24 is not accepted. Though your blockchain you have rectified, you cannot rectify world's all blockchains, and hence your chain will be disregarded after some time. They will not accept it, right? So that is what we tend to use, and then we have what is called a Coinbase. So Coinbase is when the first time the transaction is created, you will get a deposit which is done to that. So after that, a list of transactions can be created, and then it continues forward, right? Each time a coin is created, you get some this thing. So let me go back to the slides again. So hopefully you have understood what I am. So you can go and upload, you can go and follow these, follow this Anderson's link, which is given under andersbrownworth.com, and you can play with it for some time. You will understand what it means, right? So this is what I was talking about, what is a nonce, right? And the Merkle root of that, Merkle root, of course, you can just check and then you can find out what is the Merkle root value, and then the previous block hash value and the block header value total together, you will get the block ID. So that process continues. So what is important is the process called mining. Okay, mining, if there are no miners, blockchain will stop working. Now, what is important here, of course, we are not interested in how to do mining and what will I get if I mine it. I may not get the money, or I may not be interested in that money. But what is my interest? What is my interest is, now blockchain is used to store variety of data. You know, the applications of blockchain, so many applications. It is not only cryptocurrency. That is what is interesting for me. If you ask me why I'm passionate about blockchain, or why I want to share about blockchain, or why I want to excite you about blockchain, is because the applications of blockchain are tremendous. Because it is very difficult to break a blockchain as of now. But of course, I was very excited to hear also, because we were having a workshop on quantum computing, which was conducted by Microsoft, and we had about 6 days lectures. And in one of those lectures, it came to be discussing that if the quantum computer is fully realized someday, right? Because as of now, the trial versions or a smaller miniature version or proof of concept versions are running. A real quantum computer, once it comes up, the leap of computing will increase some 1,000 times. No, that's huge increase, right? And then if you want to break a blockchain, right, then it'll be easy. As of now, people are using different technologies to solve the blockchain crypto puzzle, but then breaking the chain itself may need a quantum computer, and once it comes, then the blockchain will be gone. So you can attack a blockchain, because any cryptographic code can be broken if you have infinite power, right? And quantum computer can give you an infinite power. And then, of course, this also challenges and excites me to go into try to see how you can use quantum computing to make blockchain more strong. Right? These are some thoughts which we try to look at. And at that time, I was also wanting to mention one thought with you. I don't know how much interested you are in security, but you must hear the word dark web. You must have heard the word torrent, right? And then lot of transactions are happening below at that point, and hence it is very difficult. Give me a minute. I'm in a lecture. Can you call me back later? This basically the thought process of this dark web. Dark web has a lot of content which is not there on the surface web. Whatever we are using a normal browser like Microsoft Internet Explorer. Of course, Internet Explorer is gone now. A new Microsoft browser has come, or Mozilla or Google Chrome. Using this, what you browse is called surface web. If you go deep inside a little bit, there is something called dark web and there is something called deep web. Right? These are webs which cannot be directly accessed using normal browsers. What you need is a browser which is called a Tor browser. Tor project. Basically, they are looking at anonymity. So you can be anonymous. Nobody will know who you are there, right? And lot of illegal activities, illicit activities are going on there. Any of these, marijuana or any of this drug abuse or LCD, any of these materials that these days a lot of youngsters are also using, and most of the educational institutions are affected because of these drug abuse. And most of these content is available below in the dark web and deep web, and it's very difficult to access. A lot of child trafficking, women trafficking, and pornographic content is put there. A lot of illegal arms, botnets. You can easily buy a botnet going into torrent, and lot of content is available. And of course, it is all coming together, right? So dark web transactions are made using blockchain. And a technology which can break it is quantum. So you can try to combine these things, right? So as an academic interest, I'm trying to work a little bit on dark web. So these are all challenging things that you can think about. So whenever new topics come in, please do not be afraid, because that is what it means. That is what technology means. Being teachers and being researchers and being students, the thing that we must not be worried about is new things, new concepts. They are difficult, they are hard. Of course, I can understand the ma'am who asked the question. I did not understand what is nonce and what is a Merkle root. It takes time. It's not easy. In the first attempt, it may not be very easy. But as you continue to read, as you continue to look at it, you can do it. So the point that I'm talking about, of course, I'll quickly pass through mining and then we'll go into security. What mining is, it needs to solve a puzzle called proof of work, right? So this proof of work is possible. I will show you that basic steps that are there. It involves a brute force computation to spend where it requires a lot of resources. So what happens? It scans for a value called the nonce. Right? So what you need is you have to scan for this value called nonce, and that when hash results in a hash beginning with a set of number of beginning with zeros. So that's a condition. This is what we have to achieve as a result. Right? For that we have to find the nonce. So that is a secret. That's all proof of work involves, right? So what happens? So you want to create, we have discussed all this, right? So what you have to do if you want to mine, you download the entire blockchain, then you verify the incoming transactions, you create a block, find a valid nonce and broadcast your block. If the block is added successfully, then you will get what are called bitcoins. You get a profit. So this is what the mining process, and a lot of people are got into this mining process. So this is what happens. So there are once you create a blockchain of your own, you download the existing blockchain which is there. You can go and just search on Google and find out the latest blockchain. What is the latest stage that is there? All the transactions can be downloaded, and you can upload to the latest update to the latest transaction. So then, if you are one of the node, you will get the transactions. Then what you can do? You can put these transactions in a block, go to the select the header of the most recent block, insert it into a new block as a hash, solve the proof of work. This is the mining algorithm that is happening. That is, find the nonce. Just find the nonce, and once the solution is there, the new block is added to the blockchain. But then, who solves the proof of work first gets to add a block. If you've not solved it on time, then you have to look for the next block. Then if you're not able to add it, then you have to look for the next block. So what is the shortcoming here? The resource. Whoever has more resources can do it. Mining a block is difficult because SHA-256 hash of a block header must be lower than or equal to the target value. The target value should start with some set of zeros. So that target value is each time changed also again. So that is something. So what you propose a new block, you take the header of the most recent block, combine and create a hash with the nonce, right? And then find out the hash number. Is the hash number less than the target value? Then you are successful. If it is not, go and repeat the process again. Find out the nonce, propose the new block, header of the new block, combine, get the hash, check the hash less than target value. If it is not, this process repeat. This is called mining. And if its hash value is less than the target value, then come and compare. Then the target value determines the mining difficulty. And then of course, if it is a hash, if it is a yes, then you get the proof of work solved, and then you get the reward, right? So this is how it continues, right? So this is what actually happens. So this is a bigger slide that you can try to look at the whole thing, how it looks like. So this process is mining. If the hash value proof of work solved, hence you are getting a mining reward, right? So this is how mining process works. So later, earlier there was what is called CPUs were used, then later GPUs were used, graphical processing units. For deep learning and other things, you must be started using GPUs. Parallel computing, you would have used GPUs. So that is where. And then the next one is the ASIC mining, the ASIC, application specific integrated circuit. So a mining circuit is created, an entire processor is created only to solve the mining issues, right? Just these steps, only these steps are implemented into a chip. And then it is even faster than GPU, right? When the first Bitcoin was released, one could mine 100 Bitcoins using a CPU, because at that time nobody knew it 10 years ago, right? But now Bitcoin mining hardware like ASICs are high specialized computers used to mine Bitcoins. And then pools, I mentioned the word pools. What is a pool? A single individual cannot do it. So what is happening? Hundreds of individuals are coming together, combining all of their resources, then forming a pool and trying to create new blocks. And then the money that they are getting, they are sharing among themselves. So ASIC is a microchip specifically designed to execute a hashing algorithm as quickly as possible. So ASICs cost a significant amount of money because to run those ASICs, you need huge electricity, huge power. Earlier, you used to run simple CPUs, then a combination of CPUs called cluster. Then you created a big data center of CPUs. Then you created GPUs. Then you created a data center of GPUs. And then you moved into what is called ASICs, and a group of ASICs put together. All these things, but then huge expenditure in electricity because huge power consumption happens, right? And cooperating miners pool together. This is the word pool, so that they share the rewards according to their mining power. So then one of my students actually worked on ASIC resistant mining. We are amazed that this is what is happening. We are already surprised, but then people are thinking about ASIC resistance mining, because the blockchain is basically one CPU, one vote. Right? One CPU, one vote means it must be divided across people. People must not dominate. So that is what was there. So what happened? Now ASICs, they are trying to create powerful mining farms, and they are taking care of a huge percentage of the hash rate. They are able to easily reach that hash rate, right? So then new algorithms were developed, right? ASIC resistant mining algorithms are developed. Right? And they are placed on the hash cache, and there is another called proof of stake. In Bitcoin, it is proof of work earlier. In Ethereum, it is proof of stake. So you can go to this GitHub and look for these new ASIC resistant mining algorithms, and you can look at that. These are some algorithms if you want to understand equihash and ethash. So you can look at these mining ASIC resistant mining algorithms, right? So of course I'll skip some things. Though, why is immutability in blockchain? Because why things cannot be changed? Because of what is called an avalanche effect in cryptographic hash function. So slight change in input can cause significant unpredicted change in output. So any change that you want to make, it is going to be an avalanche effect. Have you seen? It is not only that you have to change your entire blockchain, but the next, all the blocks from where you want to make a change, Anyway, the blockchain has started. You can't do anything to the Genesis block. If you want to change the Genesis block, some 650,000 blocks have to be changed. And not only in your blockchain, you have to change in all the blockchains. So let us say last 10 blocks, you want to make one transaction change. So what you have to do? You have to make the change in all the transactions in the blocks, or you have to manage that the blocks are, as they get approved, you have to ensure that more people will approve your blockchain as the official one. So this is what we'll try to understand a little later, right? So that is how the immutability is, because as each blockchain changes back to the previous block, change in a data in a transaction will have to result in a change in the transaction, which will result in a change in the hash, which will change in the result in the hash of the next block. So these many changes have to be made if you want to make one change. So difficult to change a block without mining successive blocks. So all these blocks you have to keep mining and keep it in advance, and then you announce them at a certain time. So there's an attack called double spending in blockchain, right? So before we start off, okay, maybe I'll give a break here, and then can you, if you have one or two questions, maybe we can take, because we are moving into the attacks portion or the security portion. So maybe if you have not understood anything till here, maybe one or two quick questions I can take. Okay, don't worry, it will take some time for you to sync. Okay, any new technology, once it is thrown at you, of course, some of you would have read blockchain, some of you would have started working on blockchain or reading on blockchain, so you would have understood. But for others, it is something like this. Yesterday I was also, while I was listening to the quantum computing lectures, a lot of things were very difficult to grasp. Right, but yeah, first time, second time, third time, as we continue to read 2 or 3 times, right, then you will be able to answer. Initially, a lot of things were confusing, right? And of course, last year we had an opportunity to discuss on blockchain. We had some experts coming from different companies to come and share in one of the workshop that we had. At the time, we had some more learning, right? And as I keep presenting, and as participants keep asking some questions, when I am not able to answer, I have to apologize. I say I'll get back to you, and then I dig out and I sit with students and then read out, and then we try to prepare. So these slides have built over a period of time. It is not that in the very first instance I had all this knowledge. So please don't worry if it is not syncing immediately, right? But as I suggested, you please see the video Blockchain 101 in YouTube. You can go and check it out, and you can check this Andrew Brown this tool that I've shown, how the blockchains are created, and then you will understand how it goes, right? So the immutability, if you want to make one block, one change in the, so you have to make all the blockchains to be, it's very difficult. So let's try to understand what is double spending. Double spending is Gillian has some bitcoins, and then she promises some money to Nader, and while she is doing, she is also paying to Brian. Okay, she wants to use the same 10 bitcoins. She has 10 bitcoins. She says, I will give you 10 bitcoins. I will also give you 10 bitcoins. When there are only 10 bitcoins, you cannot give to 2 people, right? So, but in a blockchain, you can try to attempt that. So what happens, the transaction which gets the maximum number of confirmations from the network will be included in the blockchain. So what happens? So this is one person, and she's giving the 10 bitcoins to both of them, right? He also is getting 10 bitcoins. He has also got 10 bitcoins, and the transaction is completed here. But the transaction, as it moves, people have to agree to that block. So as the blocks are getting added, this transaction gets approved. So once the 6 blocks are added after this block gets a tick. Similarly, here there is one tick which is coming, and then as you keep adding the blocks, no blocks are getting added. So what happens? This block gets abandoned. Once this block gets abandoned, this transaction gets abandoned. So this fellow says, I have not received the money. So this is where blockchain avoids double spending. So somebody has to verify. Now what has happened? 6 people are verifying here. Now what is a double spending attack? If I can get 6 people who will say that this transaction is correct, so I can give the money here and I can dump this without getting that. So I have to get 6 people approve here and 6 people approve here, and then I can add these blocks. But only one of them will get added, and hence obviously there will be a integrity which is maintained. So that is how double spending cannot be. But then the problem is when you have a 51% attack. What is a 51% attack? What if an adversary controls 50% of the total network hash power? So every alternate block an adversary is able to add, an attacker is able to add. So whenever a chain is behind the honest network chain, she will always able to catch up and outproduce the honest miners. So what has happened? Honest miners are adding sincerely, but she has a lot of power and she is 50%, all the others are 50%, right? The moment she has one edge, that is 1% more, the other 49% are going to fail. Though they have honestly added, they are belonging to different people, but this particular one adversary has a group of people who are rallying behind her and they are approving her transaction because there is nobody to verify. So obviously, if there is a slightly more power, you will be able to give this 51% attack. So this is some of these things. So Bitcoin basically assumes an honest majority. A malicious majority can control the network. So honest majority. So what blockchain is built on? The blockchain is built on trust that many of them will be honest. Okay, if I group up, if I group with together, so let us say there are different individuals here, but Gillian, 1, 2, 3 Gillians. They are actually two different individuals, but they are actually working on behalf of Gillian. So what they do, all these transactions which are happening, okay, so if there's 2 people here versus 3, so Gillian will obviously win. And then he is blockchain. This is an illustrative diagram to give you an example of how it goes. So if the honest majority, the moment the honest majority goes on, because it's very difficult, of course, it's very impossible to get 50% of the control. So it's very difficult, but at the same time, it is not an impossibility. If somebody gets enormous power, if he can invest in that and get that resource, he can easily do that 51% attack on blockchain. So that is something. So extremely expensive for blockchains, but it gets much cheaper for newer blockchain applications. And somebody has done a research that on Ethereum Classic, you can spend as much as $1.5 million to execute a 50% attack, which has a market cap of 2 billion. So 2 billion is 100 times, and then 1.5 million you can execute a 51% attack. But of course, nobody is spending that kind of money to break, right? Then there is a selfish mining attack. What is a selfish mining attack? You do what is called a block withholding. What is block withholding? Selfish miners, there is a group pool and they mine in their private chain. They keep adding their blocks. The honest miners mine on the public chain. The selfish miners, after some time, publish their blocks when the length of the private chain is equal to length of the public chain. So what happens? They create a private chain length which is same as almost the public chain length. Then what happens? All these suddenly they add it to this length. So what happens? All the selfish miners, when they put their mind together and they work together, they create a private chain and suddenly they add it. So what has happened? The blockchain will be split into 2 parts. Whatever is having more length will be treated as authentic. So what happens? Immediately the public chain becomes invalid. Once the public chain becomes invalid, all the honest miners will lose their previously earned rewards. So these are some things. The explanation is something like this. There is a honest miner which is going like this. They build this, but there is a selfish miners who are building these blocks, right? So what has happened? This block is coming, but they are again going on building new blocks. So what has happened? This is 1, but this is 3. Suddenly the block, once it goes, this list becomes bigger. And they approve the transactions which are going on here. And these blocks are not being approved because there is a big list which is created here by a pool of selfish miners. The honest miner could not add 2 blocks, but these fellows have added 2 blocks. Once this is more than this, immediately they have shown a link which they added here. So what happens? This becomes official block 3. This becomes dropped. So people who mine this, actually they should get the money, but the selfish miners are getting the money and they share the money. So this is how a selfish mining attack happens. The DDoS, the distributed denial of service attack, can also happen on this thing. So minimal adverse effect due to a distribution network, because it's very distributed. It's very difficult to create a distributed denial of service attacks. But of course, people have launched DDoS attacks by competing miners, effectively taking them out of the network and increasing the malicious miners' effective hash rate. What has happened? They try to remove some legal miners, right? So two competing miners are competing, but one fellow loses the connection to the network, right? So they are attacking their systems, right? And honest miners waste their time verifying fake transactions. Somebody puts a lot of fake transactions, and those fake transactions some honest miners are actually fulfilling. But what is happening? By the time they do the transactions, they see that the transactions are all fake. These transactions have actually never happened. So the honest miners which have been added lose the things. So there are two ways of doing things. So there's also something called an eclipse attack, right? What is an eclipse attack? A group of malicious users can filter the victim's view of blockchain by controlling all its incoming and outgoing connections. Now, what you can try to do is a blockchain network is created. Now I am seeing what are the transactions which are happening in the blockchain. But what I can try to do, I can try to create, I sit in between, somebody is actually querying the blockchain. So the blockchain is sending the result. So I am sitting in between. Okay, this is like a sun coming in between the earth, coming in between the sun and the moon, or the sun coming in between the earth and the moon. An eclipse is created. Similarly, an attacker comes in between. So what is the actual information which has to go? It is modified here, and a modified information reaches here. So what you can do, you can make changes to all these incoming and outgoing transactions which are coming here. He is querying, but he gets the wrong information. So there's an eclipse attack which happens, right? This isolates the victim from the rest of the network and the true picture of the blockchain. So what is happening? This is the true picture, but this has been malicious. So I am getting wrong information here, right? Because this has been cut, right? So he is getting wrong information. The attackers can make a victim believe some of the absolute view of the blockchain that it wants. They think that this is so they spend a lot of time on creating new blocks, but then suddenly they realize that they have lost touch with the actual blockchain. There are some privacy attacks also. Security attacks are there. There are some privacy attacks. What are the privacy attacks? As you know, there is an address, right? So very difficult to know who this address belongs to, right? We don't know who this address belongs to. We know that this much money is there, this balance is there. Okay, he can donate, he can pay, and he can receive payment and all these things. Because blockchain is considered anonymous, each user is identified by address only. That's all. No name, no address in the sense, no physical address, no email address, nothing. No identity at all. Only 31 bits or 32 bits, I think this is, right? So it can generate as, and then you can have one account and many addresses, right? You can take what is called a post box number, right? So like that you can have 10 post boxes. Nobody knows where the physical address is. Nobody knows who the person is because the post box number is not revealed. Okay, who is the owner of the post box number is not revealed. A blockchain is replicated at each node, and observer can use the transaction history in the blockchain. You can find out the topology of the network. You can find out the patterns of the transaction. You can find out the patterns of the user's interaction. Now, what has happened? You download the entire blockchain, right? The blockchain is running now into about 420, 430 GB now. Maybe 500 GB in some time, right? So all the 500 GB of data is downloaded. All the transactions are available to you. Now what you can do, you can pick up any address, 31-bit address, and scan through where all that address is available, right? And you can create a database of some X. We don't know who that X is, that's a different issue, but we know that the X has made all these transactions to so many people. X is always transacting to some Y, or X is transacting to some A. Like some kind of a relation, some kind of a topology can be built. And you can also get some physical idea. Based on the address, you can get some idea about the geographical use of it, right? So you can try to build that. So observer can use the transaction history. You can find out the topology. You can find out the patterns. You can find out the user's interaction. So you can also map to their geographical location using that. So these are where mostly people are using blockchain in US, in Europe, and in some part of these countries and some part of this thing, and India very few parts, right? Bangalore, Maharashtra, and some of those places you have, right? But the most part is in Europe and in US, right? So a lot of transactions going on in China also. A lot of transactions are going on. So you can get that. So you can see Singapore also a lot of transactions. So these are some small countries, and you can get these Bitcoin node distribution graphs, right? So people have generated these graphs, so you can see how they can do it. So a transaction network can be developed to study the flow of Bitcoins in the network, right? So users network can be developed. So who is owning, who is spending, who is buying how much, who is selling. We don't know who the person is. That's okay. But you know that so many people are buying Bitcoin, so many people are spending Bitcoins. It's a useful information which is there. And using the transaction patterns and information gathered off the network, an SOC can attempt to de-anonymize the users. You can try to find out each time a block is created, the pool is mentioned. And the pool makes some transactions. The Bitcoins that are earned, so you can map the address, and then you know where the money is deposited. So each time the person makes a transaction of a particular pool, you can follow all the transactions made by that pool. And then you can come to understand, okay, this fellow is interacting with all these people. So you can build a knowledge base. Of course, you may not know who the person is, but still there is a lot of data coming up. So mapping the Bitcoin addresses with their real world identity. Sometimes you know that their transactions are made, the money, it is converted in a Bitcoin exchange, the money is received. So you know somewhere going that Bitcoins were converted into a kind of a currency, different currency. From cryptocurrency, it has become normal currency. So you know that, whenever money is stolen, how do you recognize? From a bank account, some money is stolen. How do you recognize it? It is very difficult, but you know that money which has been stolen has to be withdrawn and converted to physical cash. What is the use of keeping it only as a transaction? There is no use. It has to go into some other bank account. From that bank account, it has to go somewhere else. So you can track all these and then build a case. So you can try to get as close as possible, and you can make it pseudo-anonymous. Real world IDs can make it pseudo-anonymous, right? A payment to a vector whose address is scrapped off the internet. So many times addresses are scrapped off. So it is difficult to find out. All input addresses belonging to a same user as transaction is generated from one source. Most of the time you see there are multiple sources. They are sending to one individual. Maybe some payment is coming. So you know that there are so many people are making a payment to one person. So you can again try to understand how much money is going to whom and why it is going and why all these people. You can build a relation between all these people send money to this person. Why do they send? You can build a logical situation, right? So then you can do a transaction network analysis. What is a transaction network analysis? All change addresses and original addresses may belong to the same address, right? So sometimes the transactions, you can keep tracking the transactions, right? So you can get how the things are going on. 4 are going to 1 plus 3, 3 is going to 1 plus 2. So all these transactions you can find out, and then sometimes if it is going to the same address, then you try to understand that, okay, there is something which is happening, right? So then later, now what is actually happening, blockchain is moving to version 2.0. So what is happening, you are trying to create so many applications, called DApps or decentralized applications. Okay, some of them are supply chain management, land registry, healthcare, and many more. One wonderful example I would like to bring in is what is the land registry, right? Now, when the land transactions are made, right, it is very difficult to register property. You have to go to the registrar's office, land registrar or house registrar or a flat when you buy. There are a lot of money which is charged by the registrar, and of course a lot of bribes are also charged by the registration office. Very difficult. You want to get a license in a RTA. Sometimes you have to pay money and bribe, get the vehicles registered. Whenever there is any change, whenever there is a address proof change, or for everything there is a lot of bribes which go involved. But if I use blockchain, if government moves into using blockchain, right, and then the land registry, all the land documents, you cannot make a change, because you have to, if you use blockchain, and if somebody has to make a transaction change on the blockchain, it will be very difficult. You can't change the land records, you can't change these things because they are already placed on the blockchain. You cannot break the code. So that is something that we can look at. So there are so many applications which are generated, and I don't think I'll be able to go into all these, but you can try to understand that blockchain is not just for cryptocurrency. Blockchain is now used as a trust mechanism. So one of my student is working on trust in IoT, Internet of Things, trust management, right? And then she designed a paper on trust management using blockchain for Internet of Things. Wonderful. So blockchain is not only for cryptocurrency, but you can use it for many things. And then because of that enormous use, blockchain will be attacked. Wherever there is money, wherever there is good utility, many people are using something, then people will attack it. So I think that is something that you can try to look at, right? So then there is healthcare, where of course, Indian situation, we don't have these insurance issues, and we don't have who will pay the money and all that, right? But in US and all, when you go abroad, you need a real health insurance. Without health insurance, they won't allow you to step into the country, because healthcare is very costly. And because healthcare is costly, health insurance is also very costly. So what happens? All the medical records have to be kept very sure. So there must be secure recording and sharing of medical information. So what happens? To verify the patient health information, it can't change. The perform unchangeable medical audits and integrity of the clinical research, data safety, and fraudulent drug dealers. All these things, it's so difficult these days because some medicines are very costly. And once they know that certain person is having a problem with this particular health, and he has to buy this drug, so he has to pay a lot of money. So these drug dealers, what they do, they then increase the price. They create a shortage. So it is very difficult. So if a person can be identified that he has to use this medicine, and this medicine is very rare, then you can increase the price, because you can make it rare, right? So all this information is very important. So hence that is the thing. The second thing that people use blockchain is for smart contracts, right? Any agreements that should not be changed. Whenever there's a contract, the contract must not be changed. So if you want to keep that, right, a smart contract is a code that facilitates, verifies, or enforces the negotiation or execution of a digital contract. A trusted entity must run this code, and hence what you can do is you can use blockchain to create that trusted code environment, right? Ethereum is one decentralized platform to run smart contracts. So if you want to create a smart contract, if you want to, of course, people are attacking smart contracts also. But how do you test it? So you can create, you can set up Ethereum, and you need a very powerful machine. That is what is the only need. Then you download the Ethereum code and set it up, and then you can connect to the real world Ethereum entities, and then you can create smart contracts, and you can store the data, right? So there are two languages where you can learn new languages. Of course, they are beyond the scope of this seminar. I may not be able to discuss much on that, but Solidity and Viper are two two languages which you can pick up, and of course my students have studied and they are working on this, so they can do that. So the Solidity is the tool, and you can download the documents from this information. And there are two different editors. One is called a Remix editor, which you can download it from Ethereum website, and then you can also use the Visual Studio Code, that is Microsoft Visual Studio. Earlier we had Visual Basic, Visual C++ and all. So that part is called the Visual Studio Code. Code extensions are available for Solidity. So you can download the material from here and you can read it. This is how a code looks like. If you want to create a transaction or a smart contract, so you create a transaction like this, and then you look like that. So this is a simple sample program for a coin. Solidarity is the extension. So .sol is the extension. A simple contract to mint and send coins of a cryptocurrency. So how do you create? You write a function called mint, and then you write a function called send, and you can create. So the kind of blockchain kind of a mechanism can be implemented here. So that is Solidity. So lastly, before we need to understand the vulnerabilities in smart contracts. So there can be different vulnerabilities which can be caused. So these are listed: call to the unknown, out of the gas, send, and exception, disorder, typecast. So you can see that the called function does not exist, right? You call a function, but the function doesn't exist. An unknown function is called, right? feedback of the callee is executed, or these are variety of source code vulnerabilities. Then you can have the EVM bytecode, the virtual machine executable virtual machine bytecode. There may be a bug, or there can be an ether which can be lost, or there can be a stack overflow. So all these things, the number of values in the stack when it exceeds, because the stack size is 1024, you can have that, or you can have maybe the blockchain mechanism, some unpredictable state or some randomness bug or timestamp dependence, which can be changed by a malicious miner. So these are vulnerabilities in smart contracts. Then there is something which is called a DAO attack. DAO stands for Distributed Autonomous Organization. It's a small smart contract deployed in Ethereum to implement a crowdfunding platform. So it raised $150 million, but 60 million were stolen. So attacker exploited a re-entrancy vulnerability, and people used Ethereum, which is a blockchain which is very robust, but still things can happen. So these vulnerabilities exist in the way the things are happening. So there are a lot of blockchains where performance issue, the Bitcoin can handle only 3 to 7 transactions, and Ethereum can handle 15 transactions. So performance is a challenge. Inefficient technology design also. A number of smart contracts deployed on Ethereum have vulnerabilities because of the coding. In Solidity there may be issues. In Ethereum code there may be issues. And proof of work mechanism consumes a lot of energy. This is an issue where if you want to look at. And security, blockchain is as secure as its underlying cryptography. If the cryptography fails, if the hashing fails, if the 51% attack or privacy issues or network level attacks or key management attacks, any of these security issues may be there. So is it all theoretical? No, it is not theoretical. You can actually have hands-on. Right? Of course, I cannot teach you how to do a hands-on thing because of the limitations of resources here. But what we can try to do is you can set up your own Bitcoin. What you need to do is there is a Bitcoin GitHub repository. You can download it from the source from GitHub. The Bitcoin core source can be downloaded, and then you can set up a directory where you can download the blockchain data, the memory pool, and the UTXO data set. So the transactions data set of transactions which have happened till now, the entire UTXO set is also available. So then you can select a network that you want to connect to, or the main network or the text networks, and then you connect. Then you can connect to all the peers. We are there. You need a DNS entry which may be needed, which you will have to do. In an institution, it will be easy for you to create a DNS entry for the network that you want to connect, and then you download the Bitcoin blockchain, and then you then update it. Then you will know all the transactions that are happening, and you can check it out, right? So you can also have what is called a wallet, the Bitcoin QT. So the wallet is where if you want to make transactions, this is a free wallet which comes along with Bitcoin, right? So you have this thing. And there are different platforms. The main platform is Bitcoin Core, which I talked about just now, Bitcoin Core. This is the Bitcoin GitHub. The Bitcoin Core can be set up. So that is the basic blockchain, the primary blockchain. The secondary level blockchain is Ethereum, which is a decentralized platform that runs smart contracts. And you can create applications that run as a program without any possibility that downtime, censorship, fraud, everything is possible because of Ethereum, which is a public chain, right? So you can create a simple blockchain, a personal blockchain on a single system. This is called a one-click blockchain, Ganache. Then you have Parity, which is an Ethereum client. You can connect to Ethereum blockchain using ETH Core. And Solidity is the language for implementing smart contracts. So this is the language that I talked about. Then Drizzle is the front-end libraries to write distributed application front-ends. DApp stands for that. Then Truffle is a blockchain IDE and testing framework. So there's an IDE for testing your own applications. The Hyperledger is a big platform. Another open source mechanism. You can create your own blockchain using Ethereum, or you can use Hyperledger. And Hyperledger is built by the Linux Foundation, and it uses Node.js and Linux and Linux Foundation networking and Cloud Native Computing Foundation, all these things. So these are, again, blockchain itself is so difficult, but then there are varieties of public blockchain and private blockchains can be created. Public blockchain is Bitcoin and Ethereum, or public blockchains, private blockchains can be created like Hyperledger, and of course Ethereum is also can act as a private ledger. But in that again you see, right, the smart control machine, EVM, the Burrow, the Fabric, the Indy, the Iroha, Sawtooth, different kinds of tools which are there and the frameworks which are there for that, and on top of that is the Hyperledger. So this is the biggest thing that can happen. So now so many components, as at one point of time I was looking at big data, and we were trying to understand how to go about big data. So many tools which have come up in big data, amazing. It now runs to about some 150 tools which are there. If you want to study big data, there are about 150 tools which you can start learning. But of course everything may not be important to you. When you look at the research point of view, you may need one particular aspect of it. So you download that particular aspect and start working on that, right? Blockstack is another decentralized environment. Blockstack, Bitcoin Core, that is the one thing, and then Ethereum, and then the Hyperledger, the three of them. So where users don't need to trust the remote servers, you can set up yourself, and then it provides a full stack to developers for building decentralized applications. So you can try it out. There is the Blockstack Universal DApp Store. That is a distributed application store, so you can create some, again, a lot of softwares which are there readily available to create applications, right? So that is also there. So that is called the DApp store, and I think I have covered a lot of ground. So I hope I have done some justice. Of course, still some time is there, but I've covered a lot of things and a lot of information. And of course, if you ask me practically security aspect of it, security is less in the sense when I was looking at trying to understand, I made this presentation to one team in IIT Bombay, and a lot of senior professors were there, and they were, why you want to work on security issues in blockchain? Nothing will happen, right? Nothing will happen to blockchain, so you don't have to worry about it. Then I said, sir, someday things may take a shape where some things may happen. So later when I explored, a lot of papers have come, a lot of publications have come on secure issues in blockchain. So it is time you can start thinking. Of course, it's very difficult to implement and check it out, but it's not very difficult as well, because what you need is one powerful system, maybe a 16 RAM system with a multi-core processor. So if you usually what is called a workstation, if you can get a workstation, ranges from about 1 lakh to 3 lakhs, depending on the institution budgets that you can get. You can encourage and find out, maybe in a lab you can set up a blockchain. You can tell them that we will do something on blockchain, we'll do something on setting up of these resource. So people may give, or maybe you can use, if you don't get a workstation, don't worry, start off with a normal system with more RAM, maybe 16 GB RAM if you have, it will be good. 8 GB RAM also is fine, but having a better RAM will be better. So you set it up, then try to get hands-on Solidity using those. I will share the slides to the organizers who will share them with you, and you can use them and you can read them. And the more important aspect is start building smart contracts. Maybe per se security will be slightly difficult initially, but it's not. I'm not. I'm not creating a negative opinion on security on blockchain. But I'm saying that, if you want to really do something, this is something which is very challenging. But one step down, if you want to ask me, I will say you can take up, you can take up smart contracts and issues on smart contracts. You can take up blockchain for trust in any domain. I use blockchain for trust in IoT. You can use it in different sense. So wherever you want that information should not change, you can use the blockchain mechanism, right? And then it's like kind of machine learning. Any domain you can apply machine learning, right? So that is something that you can look at. So you can take it forward, right? So I wish you all the best. I'll be happy to answer questions if any.
So participants, if you are having any queries, you can ask.
Sir, good evening, sir. Sir, good evening.
Yes, yes.
Sir, this is Vasuki. You said blockchain is very expensive, but it is India they are using, sir.
Blockchain is not very expensive. Bitcoin is very expensive.
Okay.
Bitcoin, if you ask me, it is not a legal tender in India. Right? If you make transactions, it is not illegal. You can possess a you can possess a Bitcoin, you can buy a Bitcoin, you can sell a Bitcoin, no problem. But if someday you have 10 Bitcoins and suddenly there is some problem, nobody will support you in getting you the money, because there is no centralized agency. No government agency will say that you have purchased Bitcoins, you please do it at your own risk. Nobody will say, I purchased.
Okay, sir, the Bitcoin is very risky.
Bitcoin is like a stock. The stock can fall down anytime. So that is what I would like to say. If you want to buy a Bitcoin, you can buy. You invest 8 lakhs now. Someday later, it may become 10 lakhs, 12 lakhs. You can sell it. That is what people are doing. That is what a lot of Bitcoin experts who say that please buy Bitcoins, please do business with Bitcoins. They do it because they want to sell and buy Bitcoins. But if you ask me, it is like any day if the Bitcoin becomes demonetized, right, then nobody will be there to give you back that money. That money is lost, right? So that is where the risk is. But the technology, blockchain, is something which I challenge you. Please give it it is a purely a computer science mechanism. It is hashing, it is cryptography, and it is mathematics. So those who are into these fields must take it seriously as a career.
Thank you, sir.
So would future transactions would be in Bitcoins or in blockchain in upcoming few years?
Yeah. Obviously, if the blockchain, there are people who want to break the blockchain. There are people who want to keep the blockchain secure, right? So in that case, there will be people, and it is not that all the banks will close down and the whole thing will become a blockchain. But of course, if the banks take in the root of blockchain, right? See, if you look at Indian government's statements on blockchain, they say that we don't accept this money as legal tender. Why do we don't accept it as legal tender? We don't accept it as legal tender because we can't defend. If I have to agree that this money can be considered as an alternate currency, right? I cannot defend it because at any time if somebody breaks the code, right? Indian people or Indian software engineers or Indian scientists will not be able to prove how this money was broken and or how this code was broken and who broke it and whether this money belongs really, this person has really purchased something or not, right? But a country like Japan says that you can buy and sell in Bitcoins. Why? Because it is confident. If something happens, we will find it out. They can't escape. The people can't escape. In India, it is very easy to escape because most of the time we are not very strong on cryptography. We are not strong on coding to solve these issues or trace back these issues. Right? I was watching an episode on Prime Video, a web show called God Friended Me. And there I realized in most of the episodes, I saw that how easily information about any individual, about any transaction can be obtained. Right? I will encourage you to look into those web series. It's a 20-show web series. Wonderful. In each episode, this the person is actually trying to find out and help somebody because it is purportedly it is shown as God wants to help them. But then I am amazed at the way that there is a hacker Indian hacker called Suraj in that this thing, and he brings out the information about every different individuals just from the public domain, publicly available sources, and he gets the information and people hack telephones, people know the location of if you know the telephone number, people know the location, right? So these are all common things. for them. So that is how it is. So someday it may become a public ledger mechanism also. It may become a real banking mechanism. The whole banking may move into blockchain, and that is not a very far away. It may not be a very impossible situation. But yes, we can study and we can think on those lines.
So, but why still bitcoins are illegal in India?
Bitcoins are illegal in India because they can't. Because the government cannot defend. Because there is no centralized agency, they don't know where the bitcoins are created, where the bitcoins are coming, where the bitcoins are going. So hence, you cannot buy in any shop using bitcoins. But you can buy and sell bitcoins in India. You can consider it as a stock. So Bitcoin exchanges are there in India. And of course, the Lakshmi coin has been created and formulated in India also. Right? So Lakshmi coin someday may become very popular. We don't know. So if you invest, you can invest in Lakshmi coin, but we also don't know whether it becomes an alternate currency, because earlier only bitcoins were there. Now you have Ethereum coin, you have Litecoin, you have Ripple, different cryptocurrency have also come. So government will be able to do it when it is confident that it will be able to defend that network. So when it is not able to defend that network, and the challenge is with us only, you and me and the students who are listening in this workshop. Right. So if we are able to take the challenge, right, so then we can say that yes, if we have good cryptographic people coming up, if we have good people who are working on blockchain and have understood the technology and can do mining, right? So a lot of mining people are also there in India, I am sure, right? But then they are not public, right? So that is the thing.
Students, participants, if you are having any query, you can ask. Okay, I think there is no query from the participant sides. So thank you very much, sir, for your informative and knowledgeable session. And we sincerely thankful for accepting our invitations and giving your talk. Thank you very much, sir.
Yeah, I will share my slides. Some of them have requested, so please get them from the organizers. I will send them shortly. Right? Thank you.
Thank you very much, sir.
Thank you. Thank you.
So participant, tomorrow we will having the another session, okay, and that is going to start from the 11 a.m. So it is kindly requested to you all, please join 10 minutes prior.
Excuse me, ma'am.
Yes?
You will provide feedback link on the last day?
Last day, yes. On the last day.
Okay. Thanks a lot, ma'am.
Okay. Thank you all.
Thank you.
Thank you.
Okay.